to say thank you for this morning. Thank you so much for the gift of life, for the gift of good health. And we thank you, King of Glory, for this revision lesson we are going to have. We ask that you may teach us, Lord of God, for in our own power we cannot, but with you, King of Glory, everything is effective for the glory and the glory of your name, Lord. We ask that you may guide us, lead us, protect us, and take us through this day as well. Bless our teacher and continue to make him a head, not a tail in all he does. In Jesus' name I've prayed. Amen.
Okay, thank you so much, Ruth, for the word of prayer. And I want to welcome everyone. Thank you so much for joining. It is exactly 3 minutes. So the rest will be finding us when we have already started. So yesterday we looked at how we generate. We looked at how we generate the constraints, and today we are going to look at how do we solve and how do we graph. And this approach we are using, I want to let you know that when it comes to linear programming, there are very many methods of coming up with a solution to those problems. But at your level, that approach that we are using is what we call the graphical approach. Yes, but when you advance or when you study more, you'll find out that there are other approaches we can use. Take an example. We have what we call the simplex method. We have what we call the ISO method and the rest of that. And those people are doing yes, so you'll find out that there are other approaches we can use, but the other approach is called the simplex method and other approaches. But today we are mainly going to concentrate at how we use the graphical approach. So what are the steps? Whenever you find that you have that problem or you have the scenario, first obtain the constraints. That's what we looked at yesterday. So first obtain all the necessary constraints that you need. After doing so, then you go on and construct a table. And here I'm going to emphasize what we call the intercept approach because I have found out that it is very quick for students and you don't waste a lot of time. Remember, our paper was reduced, so meaning that you must always look out for the easiest approach in order for you to use less time on the number. Then this point here of extracting coordinates. Many of you at times forget to extract the coordinates you are going to plot, yet at times they award the coordinates you have extracted. You may have your table very well, that you have drawn your table, you have included your X and Y, but you go on and you forget. Maybe you forget to extract the coordinates after plotting. So always after having your table, go on and extract the coordinates that this is 1, 2. You indicate well that my X and Y, I'll have 1, 2, I'll have 2, 3, I'll have maybe 3, 5, like that. So you extract the coordinates very well to show that these are the coordinates that I'm going to be plotting. Then after plot your points, and then after shade the unwanted region. I'm going to emphasize that we are going to mainly be shading the unwanted region. But I want to let you know that please do not cram. You can, in some books or when you look at other books, you can find that they can shade the wanted region. But I told you the disadvantage of you shading the wanted region is that at times it is like when you shade that this is the wanted region, and you have to obtain the optimal points. At times it may be hard for you to read, yet you have shaded. So that's why we emphasize that you shade the unwanted region, leave the region that is wanted, such that you can be able to read off quickly and easily the points that you are going to be plotting. Okay, now I'm going to start with the graphing approach. Now, yesterday we learned how to extract the coordinates. And now I'm going to show you how can we use the intercept. We know very well that the intercept means intersecting, or it comes from intersecting. And we have two intercepts. We have what we call the x-intercept and what we call the y-intercept. And we know that this is linear programming. Yesterday I told you that linear means you are coming up with an equation of a straight line. In order for you to plot any line, you'd need only two coordinates. Two coordinates are enough. You don't need to obtain 50, 30, 10, and the rest of that. As long as you have those two coordinates, then it means you can be able to obtain your straight line as easily as possible. So what are you going to do? I want us to start using the intercept approach for those who can adjust quickly, but those who have been using it, that is very okay. We know very well that when I have a line and that line goes like this point, this is the x-axis and this is our y-axis. So this point here, where your line cuts the x-axis, this is what we are going to call the x-intercept. Now this point here, where the line is cutting the y-axis is what we call the y-intercept. Now, in order for us to plot those points, as long as I can be able to obtain this point along the y-axis and this point along the x-axis, then it means that I'll be able to come up with my line as quickly as possible. You don't need to look out for very many other points, but as long as you have those 2 points, then it means you are very sorted. And now what you need to know that when you are finding the x-intercept, this line is the line we call y is equal to 0. So for x-intercept, your y will always be 0. And for y-intercept, this line here, we call it x is equal to 0. So it means that for y-intercept, your x is equal to 0. So for whatever thing you have, you can just equate those two, say x is equal to 0 and my y is equal to 0. And then you come up and then you draw. Take an example. In case this is our first one, maybe part A, let me call it A. You have got your inequality. And which inequality have you got? You have 2x plus 3y. And this one is maybe less than or equal to 60. This is what you are going to plot. The first thing you are going to do, you have to turn this inequality into a boundary line. So you're going to say my boundary line. And what is going to be your boundary line? Your boundary line means that you are going to remove this inequality sign and replace it with an equal sign. So you will say 2x plus 3y is equal to 60. Now, what do I want you to do? What you do next, draw your simple table. In this table of yours, you're going to indicate that this is my x and this is my y. So what am I saying? That for intercept, we have said that to get the y-intercept, I will say x is equal to 0. So I'll come here where there is x, this is the x, I'll put 0. I'll come back to my equation now. I say 2x plus 3y is equal to 60. So where there is x, I'll put 0. So I'll say this is 2 times 0 plus 3y is equal to 60. So 2 times 0 is nothing. So here I remain with 0 plus 3y is equal to 60, meaning my 3y is equal to 60. So I divide by 3, I divide by 3. So I'll find my y is equal to 60, divide by 3, which will give me a 20. So I'll come here, the corresponding value for y is going to be 20. After that, I will say now, what about for the x-intercept? X-intercept means my y is 0. So I will come here, I put 0 for y. Then I will come back to my equation. I say 2x plus 3y is equal to 60. So where there is y, I will put a 0. So I will say now this is 2x plus 3 times 0 is equal to 60. So this is 2x plus 3 times 0 is a 0 is equal to 60. So here I'll have 2x is equal to 60. I divide by 2, I divide by 2. My x will equal to 30. So I'll come where there is x, I put 30. The moment I get those values and they are exact values, there are no points. Those are the best values. You don't need now to waste more time. Extract your coordinates, that my coordinates now, x and y is going to be 0, 20, and then I'll have 30, 0. Then plot those points. You don't need to look very far. And then the only thing you need to know that when it is less than or equal to or greater or equal to, that here my line will always be a body line. It will be a solid line. When it is less than or greater than, then this one is going to be dotted line. Whenever there is nothing like equal. So you draw your line like this. In case it is greater than or equal to, it will be a solid line. You don't need to break. Number 2, I can give another example. Take an example. Even if you have, let me say you have x plus 5y is greater than or equal to 120. Still, you do the same. Come, draw your simple table. In my table, indicate that this is my x and this is my y. Since I want you to obtain the intercept, say when x is 0, always you don't need those negatives. Then say, what is my boundary line? That my boundary line is going to be x plus 5y. So for you, just drop the inequality. You replace it with an equal sign. Is equal to 120. So say my x is 0. So I say 0 plus 5y is equal to 120. So this is going to be 5y is equal to 120. Divide by 5, divide by 5. So you'll get your y is equal to 120. That is what about, is it 8? No, it's not 8. 120 divided by 5. You get your answer. So that is what you have to do. This is 30. So I'll obtain my 30. So I'll come here and I put here 30. After that, I say, what about when y is 0? Then I'll come and I say now, my y is equal to 0. Go back to the same equation that you have formed. Say 5y is equal to 120. So where there is y here is where you put your 0. So you say now x plus 5 times 0 is equal to 120. So here I'll have x is equal to 120. So here put your 120. Then after, extract your coordinates. Don't forget to extract your coordinates. And then say this is 0, this is 30, and then I'll have 120, and then I have a 0. So that is how you do it. So you don't need to have very many coordinates. Okay. You don't need to have very many coordinates. So this is what? This is 25, I think. 120 divided by 5. Okay. We can make that correction. This is 24. Okay. This is 20. This is 24. Okay. 24. So you have here, this is 24 and this is 24. So those are the values that you have. In case you have another one, let me say, part C. I'm just giving, let me give more 2. Now, for anything, it is okay. However, now I want you to take note that there are those ones that are not going to be very automatic the way you are seeing them. You may put them and you get points. But now, always, it may not be easy for you to plot the points. So I want you to first, you do for me this one quickly and tell me which points will you plot? 3x plus y is less than 9. So place your answers in the chat quickly. I want you to use the intercept form. 0 and 0. Which points will you be plotting? I want to check whether people have picked something quickly here. So put in the chat, work out quickly and put in the chat, which 2 points are you going to be plotting? So you place in the chat, form your boundary line and tell us that I will be plotting these 2 points. I want you now to plot the coordinates. You give in coordinates, Delis and Techno. I want you to give the coordinates. Give us the coordinates that you are going to be plotting. Those 2 coordinates. Okay. Ruth, check out. Okay. Okay. Very good. So those are the coordinates that you are going to be plotting. Those 2 coordinates are enough. You don't need to extract or to have very many values. Still, you do the same. You say 3x plus y is equal to 9. And now I come back. You draw your simple table. Then in your simple table, have your x, have your y. Say when x is 0, put here. Meaning that the moment you put here 0, everything will vanish. So you remain with y. So I will say 3 times 0 plus y is equal to 9. So I'll have my y is equal to 9. So here I'll have 9. Then come here when y is 0. When y is 0, I'll come and I say this is 3x plus y is equal to 9. So what will I do? I'll come and I say this is 3x plus 0 is equal to 9. So I'll have 3x is equal to 9. I divide by 3, I divide by 3. My x will equal to 3. So here I'll have my 3. Then I extract my coordinate as 0, 9. Then I extract my coordinate 3, 0. Then I will know that one is sorted. So that's how you do that. However, I've showed you when they are exact. Now you may ask yourself, what if they are not exact? What if they are not exact? What do I do? Because there are cases where you're going to find that they are not exact as you may wish. So what do you do? Now, in case you find out that they are not exact, take an example. I'm going to give you an example. Now, an example I'm going to give you, take an example. You may find out that you are trying, you're going to find out that maybe you have something like this. You have 9x, maybe plus 2y. You have 9x plus 2y, and maybe it is greater than or equal to 24. Now, what are you going to notice? You're going to notice that here, when you form your boundary line, your boundary line will be 9x plus 2y is equal to 24. Now you draw your simple table. In your table still, you'll have your x, you'll have your y. So when your x is 0, you'll come and say, I'll have 9x plus 2y is equal to 24. Now x is equal to 0, it means that the whole of this one would die. So I'll have 9 times 0 plus 2y is equal to 24. So meaning I'll have 2y is equal to 24. Meaning my y is going to equal to 12. So here I'll have my 12. Then you ask yourself, when I put 0, now you notice that when you put y is equal to 0, what are you going to have? You are going to say 9x plus 2y is equal to 24. Now, when y is equal to 0, you'll notice you'll have 9x plus 2 times 0 is equal to 24. So you'll have 9x is equal to 24. Now, you're going to notice here for this particular one that when I divide by 9, what do I get? That I'll have x is equal to 2.6667. Now, plotting this one, which here you'll write to one decimal place, always write to one decimal place. So this one is 2.7. But here you may not be accurate. You may not be very accurate. Now, the first thing always you'd ask yourself, can I be in a position to get an exact value such that I avoid points? Because always accuracy comes with exact values. Now, I want you to take note of this. I want you to always observe the value, the coefficient, this value on y. The moment you find out that the value on y, the value on this y here, this value can go through this value here, the other value exactly, then it's then now that one is easy to solve. I can easily find out that value. And how do you get that value? Now, for you, what you do, the moment you find out that I can easily get that value, the coefficient on y exactly divides the other one, then what you do, you don't need to waste time. This value, this coefficient on y here is the value you use to put here. So I'll come and I just put that value here. And then I'll come and I say 9x plus 2y is equal to 24. That will be my x. So I'll say 9 times 2 plus 2y is equal to 24. So this will be 18 plus 2y is equal to 24. Now I take the 18, this side, say 18 minus 18 plus 2y will equal to 24 minus 18. So 2y will equal to, I think this is 6, 24 minus 18, which is 6. So I divide by 2, I divide by 2. So my y will equal to 3. So I'll come here and I put 3. So by doing so, you have avoided the points and you have been able to get the exact value. So then after you go, and you say, I'll have 0, 12, and then I'll have 2 and 3 as my coordinates to plot. But I want you to observe, always observe the coefficient on 2 and the other value, the other side after the equal sign. Does it go through exactly? If it goes through exactly, then it means this value coefficient on 2, it will give you an exact value. Let me give you another example on that matter. Take an example. I have maybe 10x plus 3y maybe is less than maybe 36. You'll find out that this one, I'm going to draw my table. I have my x, I'll have my y. Then you ask yourself, what do I have? I have 10x plus 3y is equal to 36. So when you say x is equal to 0, you'll come and say 10 times 0 plus 3y is equal to 36. So you'll end up with 3y is equal to 36. Divide by 3, divide by 3. So your y will end up with, you'll end up having 12. So I'll put here my 12. Then you ask yourself, what about when I put y is equal to 0? You are going to notice that when I put y is equal to 0, I'll have 10x plus 3 times 0 is equal to 36. So I'll have 10x is equal to 36. So I divide by 10, divide by 10. You are noticing that your 10 is going to be 3.6. But the challenge with points is that you are not, it may not be so accurate the way you want. Now you ask yourself, is the coefficient on y, this digit with y, can it go through the other value this side exactly? Can it go through 36? That yes. If it can go through, now this value you have here, you just carry it and you say, I'm going to use my x as 3. So you'll come and say 10x plus 3y is equal to 36. So you'll come here now and say, my x is 3. So I say 10 times 3 plus 3y is equal to 36. So you say 30 plus 3y is equal to 36. So my 3y will equal to 36 minus 30, and I will end up with 3y is equal to 6. Divide by 3, divide by 3, my y will equal to 2. So here you'll get your coordinate as 2. Then after you extract, you say I'll have 0, 12, and I'll have 3 and 2, such that you get an exact value. Once you obtain that, then it means that you are good to go. I don't know whether we are together on that, because having 3.6 is very okay as long as you can plot it very well. Kindly let me know whether you have picked an idea on how to plot, on how to extract values when it is not exactly, when it is points. Have we got that point? Kindly let me know in the chat. Okay. Since you have got it, kindly, I want you now to try out for me this one on your own. I'm giving you this one. I want 3x plus 5y is greater than 30. I want you to give me only exact values, 2 exact values you can plot. Yes, give me 2 exact coordinates you can plot for that particular one. So let me wait in the chat. 2 exact coordinates you can plot. Okay, I'm going to look through the chat. Okay, Queen Desire, we are going to try out that. Someone has got 10, 0. Good. Okay. I think this one was very automatic. That is good. I'm going to give you another one. You are trying for me this one. This one is going to be 3y plus 2x is less than 4. Give me two. Yes. Give me two. Let me see whether you. Okay, wait. Let me change this one. Let me change. I want this. I have 2x plus Okay, I want 3x plus 2y. I think this one, okay, this one I think also it's easy. Everyone can be able to find that. That one is also okay. Okay, hope everyone now can be able to obtain. Yes, so that's what you do. Now, but we have those cases. Take an example. Here I've given you exact. I have, yes, okay. Now we have those special cases, like someone in the chat told us, what if you have this 4x plus 3y is maybe less than or equal to 50, whereby you check you don't have any. This is our x and this is y. When you say x is equal to 0 for this particular one, you are going to notice you have 4x plus 3y is equal to 50. When you say 4 is 0, so here you have 0 plus 3y is equal to 50. So you notice by 3 by 3. So you are noticing that here you are getting something of this nature. 6, 6, 7. Now, what am I going to... And when you try to check, this 3 can't go through the 50 exactly. What do? Please go on and use your decimal points, but use to one decimal point. So here, you write as 16.7. Put here, when your y is 0, write to 0 to one decimal point. But in case you have time, then here write your 12.5. So you use those ones as your coordinates. For points that are recurring, write to one decimal point because that's what you can plot on your graph. But I will show you when it comes to the graph, how we can obtain an exact value. Members, let me know whether we are fine on that. Is that okay, members? Type in the chat as I take on this hand. Yes, Faith. Yes, Faith? Oh, okay.
No, teacher, it was a mistake.
It was a mistake. Okay. Okay, very good. Members are telling me. Yes. Yes, but you can still get an exact point. Yes. Yes, you can still get an exact point, please, for that particular one. As long as you are able to think, because now that one may require you to overthink, but you can still get an exact point. Yes, Bridget, even if you have that 64 plus what, you can still plot it, use the same approach. Yes, Victoria.
Good morning, teacher.
Yes, good morning.
Teacher, I'm still confused with how you got the plots, the ones that have points.
Oh, okay, you keep on. You keep on. I'm saying, Victoria, assume this is your equation. This is your Aguilar equation you have. What you do, we
Yes,
said you first get the boundary line. So it will be 3x plus 9y is equal to 12, not so?
yes,
Now you draw your table. You say, this is my x, this is my y. So Victoria, when x is 0, you will come here and you substitute. So you say 3 times 0 plus 9y is equal to 12. So 3 times 0 is nothing. So you will get 9y is equal to 12. So you divide by 9, divide by 9. So when you place your calculator, 12 divided by 9, you are going to get your answer as 1.333333. Now here, when the decimals are many, are recurring, you terminate and write to one decimal point. So Victoria, we shall write what?
we shall write 1.3.
To one decimal point. 0.3. Then after you go to the next one, when y is 0, you substitute and then you get that. Is that fine?
Yes, thank you, teacher.
Okay. Yes, Bless. Okay, Blessing. Okay. I think you are unable to. Yes, Grace.
Hello.
Yes.
Hello.
Yes, please.
Good morning, everyone. Good morning, sir. Teacher,
Morning.
what if you have like x is greater or equal to 2?
Okay. Let's look. Thank you. You have reminded me. Now, let us talk about that. Those are special thing. Y is greater than or than X. Now, what do? You do the same. You say Y is equal to X. Now, here you draw your table. Now, whenever you find that your equation you have formed, it doesn't have any intercept, for that one, you'll still have X and you have Y. So what you do, for these values of X, for these values of X, put any value of X, 0, 1, 2, 3, 4, like that. Now, what you do, that here, from what you have formed, it is saying that Y is equal to X. So when X is 0, I will say Y is equal to, where there is X, I put 0. So here we shall put 0. So our Y will be 0. When we remove and still our Y will equal to X. So when we put where X is, we put 1, we shall have Y is equal to 1. So here you'll find that this one is going to be 1, 2, 3, 4, like that. So for you, extract those points, 0, 0, 1, 1, and the rest. In case it is maybe Y is less than 2X, whereby that here our boundary line is going to be Y is equal to 2X. Now, for such a case, still you do the same. You draw your boundary thing. You say X and Y. So when you say X is equal to 0, you are going to notice you have Y is equal to 2 times 0, which is equal to 0. So you'll have 0. The moment you find you have 0, 0, here, continue and obtain other points. X is equal to 1, X is equal to 2, X is equal to 3. So where there is X here, I put 1 here. So I'll have 2 times 1, which will give us 2. I'll put here 2. Where there is X put 2, you'll get 4. Where there is X put 3, you'll get 6. And then after, you extract your point. I don't know. Okay. Hope that is now very clear. Now, another special case we are going to meet is when we have this. Let me remove this. Hope members have understood. Now, another special case is where you have such, whereby you got Y must be less than 4. Now, what here, your boundary line is going to be Y is equal to 4. What do you do? I'm going to come, you draw your simple table in case you want. In case that is for people who don't know how to draw that line quickly. Now, this one means that your Y is equal to 4. So I'll come, everything where there is Y, put 4. Where there is Y, put 4. Y is not changing. But for X, put any value of your choice. You can put 0, 1, 2, 3. But Y doesn't change. Y is constant. So when you go to your line to plot, you'll plot 0, 4, you'll plot 1, 4, you'll plot 2, 4, and you'll plot 3, 4. Those who don't know how this line looks like, that it will be just a straight line. In case this X may be greater than 4 or maybe greater than 2, and this is they have told that maybe the number of this must be greater than 2. Still do the same, say X is equal to 2. This one means that X is not changing. So you come, you do the same. I'll come here, I say this is my X and this is my Y. Where there is X, X is 2. So X is not changing. Wherever you have X, put 2. But Y can change and be any value. So for it, put anything you want. 1, 2, 3, 4, 5. And then after extract and say, I'm going to plot 2, 1. I'm going to plot 2, 2. I'm going to plot 2, 3. As long as X is not changing. In case even these ones, in case you don't know how to plot X is equal to 0. For you, what you need to know that X is not changing, but Y can be any value. So X is 0. Y, X is 0, X is 0, but Y can be any value 1, 2, 3, and the rest. Number 2, do not use negatives here when it comes to linear programming. Avoid as much as possible to get negatives. And whenever you find yourself getting a negative, ask yourself, always there is an error somewhere that you have committed. Yes, that's what I've said. You can just plot the line directly. Yes, but some of you at times you don't know how to plot that line. And I don't want you to just cram that line comes, but that is where it comes from. That is where its origin. Yes. Now I want to, when you find Y is equal to negative X, please, that is an error. That one is, we cannot have. Yes. I repeat, for exact ones, for Y is equal to 4, X is equal to these ones, you don't need to plot. You don't need the table. You don't need. But it is, these tables are for those people who don't know how to plot those lines directly. That for you use that approach in order for you to come. That's where it comes from. It doesn't come from very far. Okay, I pick one hand and then we continue. Gerard or Shadia, one of you.
Okay, sir. Sir.
Yes, please. Yes? Okay. I think members, allow me that we continue. I have failed to get Gerard, but you can put your questions in the chat. Some of your friends will be able to respond. Yes, okay. Now, we are going to the next phase of plotting. That is the next phase. And the first thing I want us to do is we are going to plot this line. Now, I'm going to ask you, since we have looked at how we obtain the lines, can we put in the chat the two coordinates we are going to plot for that line? What are those two coordinates we are going to plot for that line? What are those two coordinates we are going to plot for that line? Put in the chat, what do you think we are going to put? Very good, very good. So members have obtained. So still you do the same, you say, my boundary line. So your boundary line is going to be x plus y is equal to 2. Always do not forget to write the boundary line. Don't just go straight to the table. So I'll come, I have my x and y. Since now everyone has understood to be 0, 2, and we shall have 0, 2. So we are going to plot 0, 2, and we shall plot 2, 0. Now, this is where I want us to concentrate on this point here. Now, when you check, I'm going to plot. Now, I'm going to do two things. I'm going to plot, but as well, I'm going to do what? I'm going to do the plotting, but I'm also going to go on and do what? And combine it with the shading. So let us pay attention. Now, when it comes now to our shading and plotting. So now I have my line. Always draw your line. This is my line. After drawing my line, I'll come, I draw another line. Very well. This is my line. Now, after drawing your lines, I will know I'm going to put a demarcation. I put a demarcation. Then I label that this is my y axis and this is my x axis. Now I put, if you notice very well here at my starting point, I'm going to put 0. I can put here 1. I'm going to put here 2. I'm going to put here 3. I will put here 4. I'm jumping 2. I'll put here 1. I'll put here 2. I'm going to put here 3. I'm going to put here 4. Now I plot 0, 2. This is the x value and this is the y. X, this is 0. Y is 2. Y is the vertical. I'll come here and I put a star here. I go to the next one. 2, x is 2. Along the x-axis, it is 2. Then along the y, you don't move, it is 0. I'll place my point here. Afterwards, I'm going to ask those are the points. Then your next question to ask yourself, am I going to use a dotted line or a bold line? Look at the inequality here. When you check the inequality here is less than, and we say that if it has no equal, then it means you are going to use dotted lines. So I'll come and I say I'm going to use dotted line. Use what? You come use your dotted line. So since now for me, I don't have those dotted points, allow me to use my free hand. I'll come here and I dot. I dot my line. So for you draw a good line, then after I will label this line. I will label this line that this line I've plotted is the line x plus y is equal to 2. Don't put the inequality is equal to 2. Now the next part is the shading. And like I've said, we shade the unwanted region. In fact, even you are going to indicate it when you're working, that shading the unwanted region. Now, when I'm shading the unwanted region, I am going to come back to what I plotted, to the equation, I had x plus y is less than 2. Now, at this point is where you need to make the decision. Then I will come. Look at your line. Your line is this line vertical. I'm going to put here A. I'm going to put here B. Putting A, this is below the line. B is above the line. So you as a person, you choose, you ask yourself, where you obtain a coordinate either above your line or below your line, or the one that you want to plot, the one you want to test. So I'm going to choose a point below. Whenever you find that your line is, you have a coordinate below here. Here, the easiest coordinate to pick is this coordinate here, which is 0, 0, because it is already below. So I'll come and I say, I'm going to use 0, 0. This is your x and this is your y. So you put it here in the what? In the inequality. So I'll have 0 plus 0 less than 2. So 0 plus 0 is 0 less than 2. Then you ask yourself, does this inequality make sense? Is 0 less than 2? That yes, it makes sense. Meaning that that region is the wanted region. So that region where you have not picked the point, you come and you shade it, you shade, you shade, you shade, you shade, you shade. In case you had picked a point where B is, let me say you pick this point here, or you pick this point here, or you pick this point here, you will notice that this point is going to be 2, 2. So when you come to test your 2, 2, you'll find out that x is 2 plus y, which is 2 less than 2. So you ask, this is going to be 4 less than 2. You ask yourself, does this inequality make sense? Is 4 less than 2? That no, it doesn't make sense. Meaning that region where you have picked that point, that is the region that you are going to come and you do the shading. Kindly let me know in the chat whether that concept is okay now. Is very fine. Is the concept fine? Can we continue? Okay, 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 okay. Now, we are going to do another one. Yes, that is very okay. Allow me now to clean this screen and then we test another one. Take an example. I have another one. I have 2x plus y is greater than or equal to 4. Now, I want in the chat, still it is you people to type in the chat which two coordinates are we going to plot. Place in the chat 2 coordinates we are going to plot. Calculate quickly. Yes, Shakira. Gills, what? Ramadan. Yes, Shakira.
Master, I was only asking that can I choose even the negatives? Like I choose like -1 plus -1 without choosing the.
Yes, it is okay. It is okay. When you are testing,
Yes.
yeah, it is okay. It is okay.
Thank you.
As long as you have noticed that when you extrapolate your line,
Yes.
it doesn't follow in that region.
Yes. Thank you.
Okay. Yes, Ramadan.
Yes, sir. We were like, after drawing that region of A and B, you choose your coordinates. One is from A side and the other one's from the B side.
No, you just
So
choose
after,
one. For you just
yes,
decide. For you, it is okay to choose just one. You either choose in A or in B.
okay. So assuming you chose from the A and B, let's say it's 1 and 4. So when you get to inequality, which side do you shade actually?
The one, the way, like you look at the point where you chose the point, yeah? In case you feel in your inequality and it is not making sense, then it means that is the unwanted region. For you ask, does the inequality make sense? If it's not making sense, then that is the one. In case it makes sense, it means that is the wanted. In case it doesn't make sense, that is the real side you shade.
Okay, thank you.
Okay. Now, hope everyone, yes?
I was asking,
Mm.
when you are drawing like these axes, the x-axis and the y-axis, like are they supposed to meet or to intercept at the origin?
At the origin. Now, they have to meet. Now, when they have to meet, but since already at times you have different scales, that's why you don't want them to intercept. Let them just meet and then have a different starting point, because you can have different starting points for both axes. So when you intercept them, at times you may write badly the starting points for each.
Okay, thank you.
Okay. Okay. Now, these are my points. So I'm going to plot 0, 4 is a point here. And then 2, 0 is a point here. Now, after drawing, you ask this is greater than or equal to. Now, you need to know that that one, we use a bold line. So what you do, you come, get your ruler. And now this is my ruler. So for me, I'm going to come and I say, this is my line. That is my line. Now, one thing I want you to take note of is that learn to extrapolate your lines, like extend them a bit. Don't exactly stop at that point. After, kindly label your line that the line I've plotted is 2x plus y is equal to 4. Now you are going to choose. We have said, look at your line. Either you have this side or this side. So I can either say, let me choose this side where there is A or this side where there is B. And there is no need for you to put a B. Just have it mentally in your head that I'm going to do this. So I've told you now, for me always, since if there is A and I notice that that line is below 0, 0, it's what I choose. So I'll come here and I say 2x plus y is greater than or equal to 4. So my coordinate I'm choosing is 0, 0. So I'll say 2 times 0 plus 0 greater or equal to 4. So here I'll have 0 plus 0 greater or equal to 4. Then this is 0 greater or equal to 4. Then I ask, is 0 greater than 4? Does it make sense? Then it does not make sense because 0 is very small compared to 4. Now it doesn't make sense. So meaning that that region where I've chosen that point is what you call the unwanted region. So you come and you shade that exact region since it does not make sense. Members, let me know whether we are fine on that. Is that okay? Okay. Yeah, Is the testing awarded marks? Yes. Show how you are testing your values. Show how you are testing your values. Don't just come out of the blue and for you put things. Take an example. I want to give now, there is this particular one that always gives you hard time for exact values. Take an example, y is less than 2x. Take an example that. So we have said for this one, still you do the same. Y is equal to 2x. Draw your simple table, have your x, have your y. Now here we shall have x 0, you'll have your y 0. Then here I've said increase the value, say 1, say 2, say 3. Now what are you going to do? When x is 1, I'll have 2, I'll have 4, I'll have 6. Now, meaning your coordinates will be 0, 0, 1, 2, 2, 4, and then 3, 6. Now, still, you do the same. Go to your graph. Have your graph. This is my graph. I'll come. I do like that. Then I'll come. I put the demarcations. Indicate very well the demarcations. And then after, label that this is 0, this is 1, this is 2, this is 3, this is 4. Now, you are not saying, according to my graph, you are not saying you have 0, 2, 4, 6. Now, please do not cram. Here, you can use a different scale. You can use a different scale. You can say this is 2, this is 4, this is 6. As long as the scale is uniform. Then after come plot, 0, 0 is here. 1, 2, 1, 2 is here. 2, 4, 2, 4 is here. Then 3, 6, 3, 6 is here. Now, after plotting, come, ask yourself, which kind of line am I drawing? Looking at your inequality, you are noticing that is a dotted line. So I will come, I will get my pencil, your pen, you start drawing your dotted line, like that, like that. But use a straight ruler, use the ruler such that it is straight. Now, after drawing that, you are going to come and ask yourself, now what next? Label your line. So this line is y is equal to 2x. Now you are going to choose the 2 points. So you can either choose this side A or you choose this side B. But you are not saying that A and B, where they are, you are not saying that there is no 0, 0. So choose any point this side, any of your sides you want. So take an example. Never and never choose a point along that line. Never choose a point. That's why always, in fact, make sure you extend below the line. Don't choose these points near, because at times some of you make mistakes. So make sure you choose a point at least very far. Take an example, I can decide to choose this point, and this coordinate is 4, 2. So I'll come back to my inequality, which is y less than 2x. I test. I say this is 4, this is 2, this is x, this is y. So where there is y, I put 2. Where there is x, I put 4. So I'll have 2 times 4, and I'll have 2 less than 8. Then I ask myself, does the inequality make sense? Is 2 less than 8? That yes, it makes sense. Now, that is the wanted region, meaning you are going to shade the other region where you have not picked the point. So I shade like that, I shade like that, I shade like that. So that is how we shade. When you find the ones that don't have intercept, those lines y less than x, that is how you shade them, and you choose either below or above it. So for any, as long as it does not make sense, then you choose it like that. Blessing, I'm seeing your hand up. Elisha.
Teacher,
Yes.
my question once again is about the, like, let's say we are talking about, actually, I think it happened with all the numbers, the part where we were about the profits, like the maximizing part. We don't have like, it's okay, like it's like 800x plus 600y. We don't have anything else continuing. How do you solve that?
Oh, now that one, we don't plot that one of 800 plus that. Is not plotted.
Okay, sir.
Yeah. But for people who do technology and design, that subject, that is the second approach, but that one I'm not going to teach it, how to use that equation. Yeah. Okay. Elisha?
So, sir, yeah, for me, what I was asking is that I'll like beg your pardon on how you obtain the coordinates.
Which coordinates?
For this part here. How
Of
you
what?
obtain this
Which
the ones of this equation, y is less than 2x.
Okay. Did you understand? Like we said, this equation doesn't have an intercept. It only has y and x.
Yeah.
It doesn't have any number this side. Now, the moment you find that it doesn't have any number, choose your values of x as you want. After choosing your values of x, fill them in that equation you have formed. That here, my x I've chosen is 0. I'll come here where there is x, I put 0. So I say 2 times 0, I'll get 0. I have chosen my x as 1. Where there is x, I put 1. So I'll have 2 times 1, which is 2. I've chosen my x's as 2. I'll come here, I put 2. 2 times 2, which is 4.
Okay,
is it
now
fine?
I've got you now.
Okay. Okay. Yes, Brighton. Now, what if the values are very big? Because here I'm using small values. Take an example. Let me give you something very big. Say you have 400x plus 300y is less than or equal to. Okay. Tell me in the chat which points we are going to plot. Hey, and I see as I answer some questions here. Brighton. Oh, Brighton, your network is not okay. Grace.
Hello, good morning, teacher.
Morning.
I have a question about the coordinates. For example, if you have the equation, for example, 4x plus 3y is less or equal to 50. And then when I'm finding my what?
Sir, how can we plot the small places?
When I'm finding my coordinates, I start with x, and I'm all like 4x plus 0 is less or equal to 50. Is that also okay? If I start
Like
with
when you're
x,
looking for what? Grace.
Sorry?
When you're looking for what?
When I'm looking for the coordinates to plot, and then I start with
it is okay, but don't put the inequality, remove it. So say 4x plus 3y is equal to 50. First find the boundary line. Don't never solve or never put in those things that you are going to plot with an inequality. Put the equal sign first. Say the boundary line is this, and then after you continue.
Teacher, another question is that our teacher always told us that they don't plot points.
Okay. Now, there are some numbers you are going to find that it will take you some good time for you to find out which number to plot. That's why I showed you that in case it is easy for you to obtain a number where there are no points, it is very okay. You obtain them. But if you scratch your head and you fail to get the number, then plot the points, but to one decimal point. Is that fine?
Thank you.
But
Yes.
I will show you how you will remove them on the final solutions. Okay. Now, I think people have given the answer 0, 40, 30, 0. So here is 0, 40, 30, 0. Now, what is going to happen? Now, for such big numbers, what you do, kindly adjust your scale. Adjust your scale. Let me say this is your thing. Now, here I'll expect that when you are plotting such, you don't use those small scales. You are noticing your values are in 40s, 30s. Now, I expect to say, now my values can be 10, 20, 30, 40. So you can say 10, 20, 30, 40. In case they're in 100, say 100, 200, 300, like that. Don't use small letters. If you see that the values are big, increase your scale. Let me say you can say 5, 10, 15. Then here you will say 0, 40, I will come. 0 and 40 is here. Then I will say 30, 0 is a point here. Then I ask, which kind of line? This is a solid line. Then I will get my ruler very well. I will come and I draw my line. Then the next thing you do, now for such equations, you can first reduce. You can first reduce it. So don't what? You can first reduce it very well for those. But since some of you make mistakes when you are reducing, I advise that if you are not very sure of reducing, work it the way it is, simplify life and work it the way it is. But if you are very good at simplifying, it is very okay, simplify it. If you know how to simplify, then simplify. Here you can notice that 0, 0, 0, 0 are common, so you can first divide by 100, by 100, by 100. Throughout, the only problem is some of you when you are dividing, you at times forget to divide this side and you end up getting only wrong things. Yet someone who filled in directly here has been able to get the right answer. So please be very, very careful on that. If you are not sure, for you work it out. There is no penalty that you have not reduced. You're fine as long as you have the right answer. Though we advise for you can reduce. We advise reducing is very okay. But if you are not sure, then kindly work out it the way it is. Then after here, I'm going to choose. So since my 0 is already there, I don't waste time. I'll say this is 0 plus 0 less or equal to 12,000. Then I say 0 less than or equal to 12,000, that yes, it makes sense. Then I'll come and I shade this side. Now, what if we have points? How do we plot those points? Take an example. I have gotten my things as maybe 2 and 0, and I've got another point as 0 and maybe let me say 4.5 or 4.3. Still do the same. Have your axes drawn very well. Have them drawn very well. Have it like this, have it like this. Then after, put this is 0, this is maybe 1, this is 2, this is 3, and this is 4. And then this is maybe 1, 2, 3, and 4. Now, whenever you have points, I would advise you to always jump to centimeters. Point will easily be indicated. Now, for 2, 0, you will notice it is easy to get. What about 0 and 4.5? I'll come 0 and 4.5. So this is 4. Now, we are going to go back to physics and ask ourselves, or in math, what does one small box contain? So when you look here, this is from 0 to 1. So in order for you to get one box, you say the upper value 1 minus the value before it, divide by how many boxes are in between, that they are 10. So then you say 1 minus 0 divided by 10. So you end up with 0.1, meaning that each of these small box has 0.1, 0.1, 0.1. So for me to plot 4.5, I will just say 4.5 divided by 0.1, and it will give me 45 boxes. Alternatively, last time I showed you, so for each box contains 0.1. So you can also come and say, this is 4, 4.1, 4.2, 4.3, 4.4, 4.5, meaning that your value is here. And therefore, I'll get my ruler, and then I'll come, I draw something that goes through like that. That's how you plot the points. So you use the same idea used when you are plotting physics graphs. In case it is maybe 4.3, you will know that, or maybe let me say 2.3, you'll come and say this is 2.1.2.3, and then I'll put it there. And then I draw. Yes, and please, I want to repeat, it is very okay because even, yes, so that's how you plot those decimal points. Kindly let me know whether we are good to continue. In case you have used the scale of 5, 0.5 is very okay. In case this, yes, thank you, goods. Are we good to continue? Okay. I think now we are going to continue. That is how we do, and that's how we are going to do the shading. Now, the next part, you have finished to do your thing, and you have finished to do the plotting, everything you have finished. Okay, now, the next one is, how do we obtain the points from the feasible solution? Now, in order for us to obtain, we are going to use what we call the corner point approach, and here is what we do. Take an example. You have finished to draw and you have come up with your graph like that. Now, in order for you to obtain your solutions that you want, what are you going to do? I want you always come and check out the corner points first. Given that those lines are giving a borderline, the points you test first. Oh, wait. Are you seeing these points here are the ones you are going to test first? This point here, this point here, this point here. Those are the points you read off first. Now you'll come and extract the first point there. This point A here is 0.8. Now what you do, when you are removing them, have your table drawn and say, my optimal points. And then I put XY. Then I'm going to come here. This is the table I told you. Then here you have your function. Let me say it is cell is equal to maybe 500x plus maybe 250y here. And this is the table, you cross it. Any point you extract, you put here. The first one I've extracted is 0.8. I will come to the next one here at the corner. That is 0.6. I'll come to another one here. This is my point C, which is 2.4. I'll come. In case you want, you can add another point. Take an example. You can take this point on the line, which is maybe 1.6. In case you want, you can also take this point, which is 1.5. Now, whenever you are reading points, we read integer values. We read integer values. Don't read decimal points. Don't come and read off this point here. Don't come and read off this point here. Only read integer values. In other words, read whole numbers. Don't read those point things of yours. Come, read off here and here. And don't read off these ones here. Read off only exact values you can obtain. Because in case, let me say, you are talking about trips. You can't have 2.4 trips. In case you are talking about this, you can't have those points. Now, afterwards, after extracting all your points, at least have 3 points. At least I've said at least 3 points. Then I'm going to come and I say my cell is given by 500x plus 250y. Now I will come and I substitute. This is x is 0, y is 8. So I will say 500 times 0 plus 250 times 8. In your objective function, the person who was asking why we have not used it, this is where you use it after coming up with your space. So here I'll get my 2000. So here I'll put 2000. Then I go to the next one, 0 and 6. Then you put, still you insert in and say, and get what you get. So you keep on inserting. Okay, let me 250 times 8. Then 6 times 250. You find this is maybe 150. Then you insert 2 and 4. Where there is x, you put 2. Here I will put now 2. Here I will put my 4. Then I will come and I say, what do I get? 500 times 2 plus 250 times 4. So I end up with 2000. Yeah. Then you put here, you put here. Now, afterwards, okay, let me put for you one more. 500 times 6 plus 500. You'll find that here, there is 2000. And now here, you are going to ask, even if you put 1 and 5, now afterwards, it depends on what the question wanted. The question might have told you that, what is the best option that for this person to minimize the costs, to buy everything that is needed as well as minimizing. Now you'll come here at this conclusion, at the sales here, or at the cost. Let me say maybe their costs or what. Let me use costs. And you ask, which option is bringing little money? Which option is saving? That this option here, where I'm using little money, would be the best option because I'm getting 1500. So I will come and I look at that combination that gives me, with that combination is 0 and 6. So when you check very well, you will notice that 0 and 6, it is one of the corner points. So in most cases, 99%, your optimal point is going to be your either minimum or maximum is going to be at the corner points. Those are the points you are going to test out. Members, are we together on that? I want to get 2 questions before we leave. Yes, Travis and Patricia.
Sir,
yes.
I just wanted to ask, is it true that every time, like, we plot and stuff, and then we draw the lines, is it true that you get a triangle or something like that?
You get a figure, you get some figure, but it's not always a triangle. It can be a rectangle, it can be any other figure. Is that fine?
Okay, thank you.
But you must remain with a region.
Okay.
Okay. Travis?
Morning, teacher.
Yes, morning.
Teacher,
Yes.
I'm asking on the part of
The part of?
first one, on the part of testing, on the part of testing for the right part to shade. We also said something else like instead of doing the calculation, just get the symbol, put it on the line. Like where the legs open, that's where we shade.
Where
But
the
for the
line does?
case of the other, like where the symbol, like where its legs open.
Where the symbol does what?
Like where it's open.
Open, eh?
Yes, that's where we shade. Where its faces now it's open. That's where we shade. But for the case of the other line that was going to the negative side, we just change the symbol to face the opposite side. Then we shade. Is it okay or we have to do the calculation part?
Better. Now, like now, if you don't do the calculation, you are going to miss out the marks. If you don't show how you have proved, because that one is more or less, I don't want to say, I know, like when we are studying, always we discover approaches. When you do very many numbers, you may discover your own approach. But I advise, show how you are getting it.
So,
okay, sir.
Okay. Yes.
So my question is, for us, they had told us that after like getting your unshaded region, let's say it's like a triangle or anything, that every part where those boxes meet, you have to put, like mark them.
Oh, okay. The reason for marking is for you to extract the points, to help you to extract the points, eh? But there is no need for you to mark them as long as you read off the coordinates very well. So it is just for easy identification.
Okay, sir. So it doesn't have a point.
Yes, as long as you have read them correctly from your shape that you have formed.
Okay, thank you, sir.
Okay. Now we have another shape. Still, when you meet such, still you do the same. Extract. Look at these corner points you have remained with. Here that I've shaded and I've got the figure. Now I look out for. The first point is the corner points. These corner points that are forming the sharp points. That's what you are going to look out for. Now, I want you to notice very well. When you look at this corner here, the value is exact. I can read off the 6 and 7. When I look at this corner, I can also read off 6 and 8. When I look at this corner here, you are noticing that this is a point. This is a point, friends. It is 8 point something, and this one is 6. So ignore that one, since you are not getting an integer value. Like I've told you that you can't say, the number of roots I'm going to make is 8.6, meaning that you leave children on the way. Then come, this one here is 7 and 6. Then in case there is any within the boundary that you can easily read, take an example, this one, I read it, I say, still that is now 6 and 7. Then the rest that you can't read now, like here, that in case you want this, these ones are going to give you points. Those ones, ignore them. So you take these ones that you can read them, the ones that are giving you integer values. The ones that are not giving you integer values, now even this one can give you, let me say 8, 6. 8, 6. I've said I have at least 3 of them, but for safety, 5 is the best. For safety, having 5 is the best. So and always prioritize, make priority of the line, those points along the line, but the most important one, start with the corners, then you can read off the ones in the line and read a few in the spaces. And then after extracting your points, feed in the objective function, and then you make the calculations. Hope that is very, very fine. Travis, I don't know whether you have something to say.
Sir,
yes.
I was asking, doesn't like does this reduction thing does like not change the results after all?
Or the
like
reduction, no,
it
doesn't.
For example, they can give you like money. Oh, like has no effect.
It has no effect, but never reduce your objective function. Okay. Objective functions are not reduced. Hey, they are not reduced.
Yeah. Yes, I get.
Okay. Another person, was it Grace? Okay, G.
Yes, sir.
Good morning.
Good morning, sir.
Yes, good morning.
I have a question here. What if I'm done drawing my lines and everything, and when I substitute in my objective function, I find out that I am given, okay, I find out that I get same values.
You get?
I get like same values. Let's say we are talking about minimizing losses, and I find out that I get 1,500, 1,500, 2K, 2K, 2K. In that case, what do I consider?
Now, that case, what you do, you test out more values that are within the unshaded region. That region, you sample out more values within the unshaded region. But that case is a rare case. But for that, such a case, you choose one value that fits the inequalities or that makes sense of the inequalities. Take an example. You might get two values, or which each of them is giving you this. Let me say this is X and this is Y. But this one is 3 and this is 6, and this is 7 and this is, let me say 7 and this is 3. And when you look at the condition, they told you that the number of trips of Y must be less than they must be less than they must be less than 4. Now here you go back, look at the inequalities, and you conclude and say, much as both of them are giving me, but it does not satisfy this inequality that Y must always be greater or equal to 4. Because here I'm getting 6 and here is 3. So the best option is this. I don't know that you have understood. Was it KG?
Yes, sir. Thank you very much. I've understood.
Okay. Okay. I think let's continue. Queen Esther, your hand is still up. But yes, Hope.
Okay, so my question is like, what if the corner points are in decimal? What do you do? Like in our school, our teacher told us that in case the corner point is on a decimal, like this one where we have 9 and 6, you can move to the nearest value, like which will be, there's this one, the other one is 8 point something and 6. You can move to 9 and 6.
Now,
Is
now
that
9
possible?
and 6, that one is not going to be okay. A 9 and 6 will not be okay because it will be out. Now, like I'm saying, I extract integer values. Extract integer. Integer is a whole number. Integer is a whole number. Is that fine?
Okay, like what if the corner points have integer values which are only, okay, let me say they are only 2. And now the middle, there are no integer values in the remaining shaded parts. What do you do?
You take those ones as long as they're integer values.
Okay.
So avoid having, because also you have to reason that value you are approximating to, as long as it is going beyond the region, the region that is unshaded, then you cannot be marked right. Here, let's avoid, like in this new curriculum, we need always to avoid assumptions. Let's work with evidence. Work with evidence, what you have. Reason basing on what you have, not what you think. For you check out, what do you have? Like in science, we always want to use what you have in order for you to make a conclusion, but not what you think is right. Okay. Then take an example for this one. Still, you extract now, but this is where now I want you to, this is where I wanted you, but for this one, I'm going to be a bit fast. But for those who know how to use the calculator, there's something now I want to add on to you. When you meet such, after drawing everything, this one can be easy for you to read. This one can be easy for you to read. Then you may check out this one and say, this one is not so clear. You may think the point is here. You may think it is here. What do? When you look at this line here you have plotted, this is the line 5x plus 3y is equal to 30. That line is intersecting this line, which is x plus y is equal to 8. Now you ask yourself, at which this one and this one, these are simultaneous equations. Those people who now use their calculators to solve simultaneously, use your calculators quickly and solve it simultaneously. Find the value of x and y, and you read off this coordinate quickly. Read off this coordinate quickly. And that coordinate is going to be, I think it is 3 and 5. So once you solve this equation and this equation simultaneously, but here I don't want you to waste time in the what? Use the calculator. Those who have the good calculators, not these duplicates. You solve it and get the value here quickly. That it is 3, 5. In case you can't read off quickly. And in other words, I'm going to tell you that whenever you find that two lines are meeting, those are simultaneous equations. To prove your answer, to prove that the point you have read out, solve them simultaneously. But using the calc, I don't want you to waste time in the calculation. Even when you look at this one, this is a simultaneous equation. This line is the line y is x is equal to 0. This equation, so you ask yourself, when x plus y is equal to 8, and it is meeting y is x is equal to 0, at which coordinates do they meet? What about here? So that is what, but I'm not going to emphasize a lot about it. But those who have picked, you can use that approach. Even those cases where you find you have this, for you check out which equation is this that you have plotted and which equation is this that you have plotted. Solve them, get this point where they meet. Check out which equation is this and which equation is this. Check out which point is that. Which equation is this and which equation is that? Which point is that they are meeting? The moment you solve and see that you are getting points, ignore that point. The moment you solve and see you are getting points, ignore that point. The point that is giving you an exact value without points, that is the good point. That one I will not emphasize, but at least pick something. Pick something from that. But those who have not picked it, yeah, but that is what I wanted to bring to your attention. Hope that is okay. Just let me, I want to find out how many people have picked something. What is its use? Is for you to get those points, the optimal points quickly. Is to help you to get the optimal points. You may find the time is catching up what, but you can use it to prove that, yeah. And those ones are the ones that are going to help you to avoid those assumptions. Because when you solve those two simultaneous equations and you find out that that optimal point is off, now the person who was telling us to approximate to 9 and 6 like this point, when you solve this equation and this line where they meet, you'll find that 9 and 6 doesn't satisfy the inequality or doesn't satisfy that equation. So that one, okay. Yeah, that one, okay. Okay, now that one, you'll try it in your free time. Okay, I think we have talked. Now, we have this one. This is one of the graphs. Now, you're going to find such cases whereby this line is a body line. You are not seeing. This line is a body line. This line here is also a body line, but this one is dotted. Now, there are cases, and that approach I'm telling you of simultaneous, it can help you to prove even your answers. It can help you, but I want you to go a bit an extra mind and find out. Even if you have not shared it, there is a way you can utilize it. Now you can look at this one. This is board, and you are looking for the optimal points. The moment this line, the dotted one, is meeting anywhere, this is the region we have remained with. Please ignore this point here because this point is being intersected with a dotted point. This one cannot be part of the solution. That one, ignore that. then the only point you should consider is the one that is bounded by the border lines. Those lines must be bordered. Now, like this point here can be taken. This one here can be taken. Then for that such a case, I've told you, make sure you have at least 3 optimal points. You are going to come, either choose a point along these lines, the border lines. Take an example, look for a point. In case there is no any, now like here, you can take this point. In case you are not seeing very many points, choose some points, sample some points within the region that are integer values, because I've told you, don't write points. The points indicate that you are going, in case they are routes, you are taking half routes, meaning that children are not going to reach school. They are going to dodge school. In case it is money, instead of giving you a full dose, they are giving you half, and you wouldn't be happy with such. So please make sure. I'm seeing some hands up.
Good morning, sir.
Yes, good morning.
I was asking that how do you obtain the other scale which you use at the first in
which scale?
The scale which you use that was it 500 x plus 250? Why?
Oh no, that one was I was just giving an example of an objective function,
Yeah.
Yeah, I was just giving, but if you can relate that number to the number we did yesterday about cakes and apples, the person who was sent to buy cakes and apples, that was the number.
Okay, sir.
Okay, yes, Daniela?
When are we going to do a full number? From the
It is the
beginning to
next.
end non-stop.
It is the next.
Okay,
Blessing?
Can I still have a problem on that thing where you have said that we use the simultaneous equation thing? When I'm done generating my things on the calc, those are like the optimal points I should use, or?
Yeah, okay, those ones can be optimal points given that those equations are not let me say, okay, given that those points are not dotted lines, those equations you are solving, but you should be able to visualize it from the graph, that you cannot use this one and this one, that one will be meeting a board point. In other words, you can only use it when you have less than or equal to or greater than equal to. So don't solve two equations whereby they are not.
Okay, sure. So that means that I can have only like one optimal point.
No, like I've said, generate more than one. But your final answer, you'll write one optimal point, but generate one. Generate more than one. Even look in those spaces you are remaining with.
Yes. Okay, so I generate many, but I use one of them.
Yes, one of them, given that it fulfills the other conditions. But like in case because remember your conclusion should be based with evidence. In case maybe you are calculating cost, sales, and you find out that maybe the money is the same. Then you go back and look at the inequalities you generated and you reason out accordingly.
Okay, sir.
Okay.
Thank you.
Okay. Trinity, now we are working on this question. Trinity. Shairo. Shairo. Unmute. Oh. Okay. Shairo, I'm failing to get you. You are not unmuting. I don't know why. I'm asking you to unmute. Atugonza.
Good morning, teacher.
Good morning.
Teacher, I was requesting that you do the number which was in the Wakisha MOOCs, the number 2.
Okay, we are going to do those numbers. It is time. I think that one, I had it yesterday, but I'm going to check. Okay, Shairo? Okay, okay. So we are going to start with this one. Yes, but the most important thing is for you knowing, if you have understood those different concepts we have looked at, there is no number that is going to fail. As long as you can generate, that's why yesterday we did very many scenarios, such that as long as you can be able to generate the inequalities, that's what is important. Even if you look at the workshop thing you are talking about, as long as you generate the inequalities, in fact, the only thing I can do for you is we generate together the inequalities, and then for you go on and solve. Okay, now we start with this one. I told you yesterday that whenever you find such scenarios, the first thing you do is you have to read through the question. Ask yourself, what is the question asking for? And always I told you that look at the conclusion. What is the conclusion requiring me to do? That's the number of trips of the lorry and the ones made by the pickup. So it means that the two variables you are going to be letting, you are going to say, you are going to come here and say very well that I will need let X represent. Ask yourself, what have they started with? They started with the lorry, and then after they came up with the pickup. So I'll say, let X represent, write in words, the number, don't abbreviate, the number of trips made, or the number of trips to be made by the lorry. And let Y represent the number of trips to be made by the pickup. Then I told you afterwards, you are going to summarize your table. But I told you it's not a must for you to summarize. Then you are going to have, what have you started with? I've started with the lorry, and I have here my pickup. Then you read the question. He has a lorry that can carry 90 bags per trip and a pickup that can carry 20 bags per trip. Now I'm going to say the number here in my summary, the number of bags that can be carried. This one can carry 90, this one can carry 20. But in total, how many bags does the person want to carry? They told that this person wishes to transport at least, we said at least means greater than or equal to. So here the total number of bags should be 240, meaning that if it's to combine a lorry and a pickup, all these 240 bags and more should be able to be taken away. Then you continue. The cost of each trip is 50,000 for the lorry and 15,000 for pickup. He has 180,000 available to transport the sugar. Then you come and say, what about the cost of transport? For a lorry, he will need 50,000. For the pickup, he needs 15,000. But how much does he have in total that this person has 180,000? Then the next one, you're going to come and say, and continue. The pickup makes more trips than the lorry. That is another statement we are going to summarize. Then come and ask yourself, what is going to be my objective function? Objective function is the one that you're going to use to determine which trip which trip can I use and how much is it going to cost me. So here I will say, now to determine my cost, it's going to be the amount I pay for the lorry and then the amount I pay for the pickup. Therefore, I'm going to come and I start writing my equations. The first one is going to be for the number of bags. Now here, lorry, we use the X. Here, we use the Y. So I will say 90X plus the 20Y. But they told you at least 240 bags. So I will say greater than or equal to 240. Now, that is the first one. The second inequality, the cost of the bags, the cost of transporting. So I will say now the total cost of transport. Then I will say I have the 50,000 of X plus the 15,000 of Y. But they told that this person, he has 180,000. Yesterday we learned about it. I want to see in the chat whether people are remembering. Which inequality are we going to use? He has. Which in okay, very good. Okay, so here, since that is the amount he has, it can't go beyond that. That is the amount your parent has given you. So you say less than or equal to 180,000. Then after that, go to the next one. The pickup, I told you that here, when you are interpreting, make sure you put the values. Pickup is what we are representing by Y. More, we said more is greater than. Trips than the lorry is X. So I will come here and I say pickup makes more is Y greater than X. Then the next inequalities I'm going to write are going to be the non-negative because you can't have negative trips. So I'll come and I say X is greater than or equal to 0. And always it must be greater than or equal to. Please don't write this one, that greater than 0. Y greater than 0. You'll be marked wrong. So say Y is greater than or equal to 0. Then the last one is the one that you are going to use to determine the minimum cost, or what we call our objective function. And what does this person want? He wants to minimize the costs. So our equation, we shall call it the costs. And I can say X of Y is going to be 50,000 of X plus the 15,000 of Y. That is going to be my thing. And now, you doing that, you have pocketed 6 marks already for yourself. How are they going to award you? Rating is that one, they can give it 1 or 2 marks. Each equation you have written correctly, please remember here we don't have that kind of mass that, this child has forgotten. Like maybe instead of writing greater than or equal, he has forgotten, he has written greater than. No one is going to have that mass on you. You must be accurate. Otherwise, if we go on with not being accurate, you may operate someone and he dies. So that's why you want the accuracy. So these ones carry 1 mark. So you have a mark here, a mark here, a mark here. For the non-negativity, always they may combine. They can give it 1, 1, or they can give it a half each. So which is about 1 mark. Then the last one, they will give you a mark. So make sure you have all of them well written. And at this level, I don't advise you to reduce anything. There's no need for you to reduce. Write them the way they are, because that's how you have extracted them from your mathematical scenario. In case you want to go on and reduce, then first write the original one and then you reduce down. But don't just come out of the blue and just say, this equation is 9x plus 2y. Don't just come out from nowhere and you say number of bags is 9x plus 2y greater or equal to 24, and you stop there. Where have you obtained it? So if you want to go on and reduce, then make sure you first write the original equation, then down is where you can write your reduced equation. Yes. So, but do not forget that if you reduce something, it means you are changing its form. Whenever you reduce something, you are reducing its form. So please be very careful with that. Kindly let me know in the chat whether we're on the same page. Yes, because we must extract all the marks. We must extract all the marks, the 6 marks for that part. Okay, now I assume. Okay, now we have the 6 marks. Okay, now we can go on. Now we are looking for, remember, out of the 20, now we are remaining with 14. Now, the 14, I want us to first capture the must ones. I want you not to miss. Even if time catches you up, don't miss these the 3 marks or the 2 marks. Now, the 2 marks are going to come from here on the graph. Even if time has caught you and you are not seeing, you look at your clock, you notice that you have 3 minutes for the paper to end. Please, I want you to just do like this. Come, look at what does the graph want. The graph, they want me to plot, the graph I'm going to plot lorry and what? Then you will just come and say, God, I'm late. What can I do? What you do, run quickly to your graph as fast as you can. Then when you run your graph, draw a line. Let me use a graph itself such that I show you what I want you not to miss. At least you must get, even this one is for someone who says, for me, I can't do that number. Even if they bring it, I just leave space. For you, what you do, go to your graph. And this one is whether you have extracted the inequalities well or you don't know. Come, draw a good straight line. Draw another one. And this is how you draw them on your graph using a ruler. Write the title of your graph. Write the title. Put here that these are lorries and these are maybe pickups. Even if you don't know what, even as long as you have read the two things that are changing, then put here some numbers of your choice. This is now time has caught you up. Put. Just shade here, shade here, shade here, shade here. And at least you have some marks there. And label your axis very well, that this is X and this is the Y axis. Put here some figures, 1, 2, 3, 4, 1, 2, 3, 4. At least there you'll have some mark for you. You can have the mark for the title, the mark for labeling the axis, and you have the mark for shading the non-negativity equations, other than scoring a 0 on that particular number. This year we shouldn't have someone getting a 0 in math completely. No, here I'm just showing you. I want you to just first get those marks before we go on today to get other marks. So please never miss those marks on the graph. Whether time has caught you, whether what or what, make sure you get those marks. So that's why now for this new curriculum, if you get a 0 completely in a paper, when you go out and you find your paper, you have a 0, there is a very big problem. So now I've showed you those two marks, but I will emphasize more when it comes to plotting. But I've just showed you that at least now those two marks for this particular number of linear programming, if God is on our side and it appears and it comes, please never miss out those marks at least. Okay, now we go to the next one. They're asking you, show the feasible region of the relation on the Cartesian plane. What am I going to do? I'm going to come on my Cartesian plane. Before I go to the Cartesian plane, we must plot the points. So how are we going to do it? I'm going to come and I say, for each of the inequality you have extracted, please go on and plot. So the first one, we have the first inequality. Now you go, you be organized. You make sure your work is neat. Whenever your work is neat, do you know that even someone can easily mark you a wrong thing because you are just neat when someone is panicking? And you have noticed even those people who write very well, at times they get even free marks or they get marks unknowingly because someone, there is a way it is logically related to the brain that if someone sees work that is very neat, he can easily mark your thing. So make sure you are very neat in everything you are doing, such that someone can mark your work very well. Now, this is the first inequality we are going to have. So I've told you always come, say the boundary line. Even right there, the boundary line. This line is going to be 90x plus 20y is equal to 240. Now, people who are interested in reducing, you can reduce at this point, no problem. Those who know how to reduce. So by reducing, you notice that 10, 0, 0 is common throughout. So you can divide by 10. And then you end up with 9x plus 2y is equal to 24. Those who want to reduce, you reduce. But in case you are not sure, you are this person who is not yet sure, for you, please do not waste your time. Come and have your table drawn, have your x and y. And we said here, we use our x is equal to 0 and our y is equal to 0, in case you see that it can be going through. Now, let me ask you, can you give me, can it go through? I will come. I say 90x plus 20y is equal to 240. When I say x is equal to 0, I'll have 0 here plus 20y is equal to 240. So I'll have 20y is equal to 240. So when I divide by 20, I divide by 20. So I'll find out that my y is equal to 12. So here I'll put 12. Then I go to the next. when my y is 0, you are noticing when I put here my y is equal to 0, I will get a decimal point. Then we say that for that particular one, you may not you may not need to waste a lot of time. Then you may look out for which coordinate can go through. So you can say, which one can I use? Then for you to come and say, I have 90x plus 20y is equal to 240. Now, for figures that are very big like this, and you don't want to plot big values, or you are not, can I say, when you are not so good at plotting big values, that's why we advise you reduce. So here, when you reduce, you have 9x plus 2y is equal to 20 to 24. Then I told you, the moment you check out that the coefficient with y can divide the other value, then this is the value you use. So I'll come here and I say, this is going to be my 2. So you say 9 times 2 plus 2y is equal to 24. So here I'll have 18 plus 2y is equal to 24 minus 18. That is what? 18. So here you'll have 2y is equal to 24 minus your 18, which will be 6. So when you divide by 2, so you find your y is equal to 3. So you'll end up with your answer as 3. Now, what about for people who went directly? Someone who went directly had 90x plus 20y is equal to 240. And you notice this value can go. Now, for you in your table, I don't know whether I can teach you this. So for you in your table, you can have your 20, no problem. And then you come here and say 90 times 20 plus 20y is equal to 240. Then this will be 20y is equal to 240. What will you get? 90 times 20, which is that, minus that. Now, here, you will notice that the value you are going to get is going to be a very, very big value that is going to give you hard time to plot. Now, for such a case, this approach cannot work for you. So that's where you go on and do the reduction approach. Hope that is very, very fine. So for these bigger values of let me say in tens and above, those ones I advise reduce them. Reduce them and then you continue. But in case you are not so very good, then I don't want you to work with the negatives. So now, meaning here, the points we are going to plot is going to be 0 and 12, and we can plot 2 and 3. But in case for you feel, even this one I've said it works when you use a 0. But here now, when you say y is equal to 0, it means you have 90x plus 20 times 0 is equal to 240. Meaning you have 90x is equal to 240. When you divide by 90, divide by 90. You'll find that the x you are going to get is going to be 240 divided by 90, which is going to be equal to 2.667. So here, what does it mean? We said you write 1 decimal point, so you write 2.7. So in case you are very good at plotting points, it is very okay. But to get a very accurate line, having exact value is more advisable. Okay. Now after that, that is the first one we have plot. We are going to plot. So here you have finished yours. So here extract the coordinates. Do not forget. Then the second one we are going to plot is going to be this equation. Y is greater than X. Now here I've told you what you do. Still you say my boundary line is going to be Y is equal to X. Then come, and I told you that for this one, your Y is equal to X, have X and Y. Whenever you find doesn't have an intercept, X values, let them anything you want. 1, 2, 3. So when X is 0, here you put 0, Y will also be 0. So I'll put 0. X when is equal to 1, I'll have 1, 2, 3. So the coordinates you are going to plot are going to be 0, 0, 1, 1, 2, 2, and then you have 3, 3. Now you have finished that line. Then the next one, now, I want you now always, now for me, what I really love, that when you finish the line, go and draw it on your graph. Don't wait to go back and go back and go back. So now the first one was 0, 12, and 2 and 3. So that one, when I go back, allow me to use this graph. I'm going to use this graph. I pray it fits. Okay, I'll use another graph, no problem. Let me use another graph. I'll use another graph, but you can first finish everything and then you go. But what I want is that when you're calculating, you leave the space for testing. Leave the space after this equation. Leave some space where you're going to test your work from. That one is very important to show how you are testing. Even you write here, testing. You write that what you are testing. Then I go to another one. Now another one is this bigger one, which has this plus 150,000 y is less than or equal to 180,000. That is the one you are plotting. Now your boundary line is going to be this plus 150,000 y is equal to 180,000. Now draw your table again. But I've said that for these big ones, it is okay for you to reduce from that point. So when you look at this one and you want, but in case you are not good, then please do not risk. So here I'll have this x plus 150,000 y is equal to 180,000. When you check out this equation, you're noticing they have zeros, 0, 0, meaning you can divide by 1,000, divide by 1,000, divide by 1,000. So 2, you remain with 50x plus 15y is equal to 108. When you notice, still you may find that there is another digit that can go through. So let me say, 5 can go through. So you can divide by 5, divide by 5, divide by 5. So, but make sure what you are dividing with divides everything. So you have 10x, this is going to be 3y is equal to 36. So then in case this is what you want to work with, ask yourself, when x is 0, what is going to be my y? Please, you are going to find out that your y is going to be 12. When I let y is equal to 0, what do I get for my x? When y is equal to 0, you are noticing that x is going to be points. Then I want you to check out this coefficient on y and this. If it can divide through, then it is okay. So this coefficient is 3. Then I'll come here and I write here my 3. Then I'll come and I say, when x is 3, I'll have 10 times 3 plus 3y is equal to 36. So this is 30 plus 3y is equal to 36. My 3y will equal to 36 minus 30. My 3y will equal to 6. So my y is equal to 2. So here I'll put 2. So I'm going to have my point 0, 12, and I'll have 3 and 2 as my points. Then, then that is the other one. Then the last ones that we have to do we have finished the first one, the second one, the third one, and I think this was the last one that we had to plot. So we are going to plot all those 3. Then for non-inequality, non-negativity, you say x is greater than 0. So my boundary, I'm going to plot x is equal to 0. So here there is no need for you to write the coordinates. Y is greater than 0, so y is equal to 0. Then those are the points we have written. So now we are going to go to our graph. Allow me now, unless someone has a burning question, I want to know, is there someone with a question? Or we can continue. Namara, I have reduced badly. It is 15,000. Where? Okay. Oh, it is 150,000. Okay. Whatever the case. Okay, they are telling me it is 15,150. Okay, let me first check. Okay, okay, I've seen. You are saying here, this is 150,000. That's what people are saying. Okay, if it is, then this one is going to be what? Okay. I think, let me be sure of the question. The question was what? It was 15,000. Yes, it is 15,000. I think it is okay. I think it just slipped where? So this was okay. I think this is where I just wrote 150. I can remove that 0. I think this was supposed to be 15,000, 15,000. Okay. Okay, I think it was 15,000, not 150. So everything is okay. Now, after, okay. Shakira, you can ask. Shakira?
Master was only asking that
Mm.
you look, before you reduce with
Mm.
1,000 or 10, you first look at the numbers of zeros you're having.
Yes, for those bigger ones, or can I say you can use the LCM if you know how to get the LCM?
Okay, thank you.
Or HCF. HCF is that number that goes through all. Or, in fact, here you can use your HCF approach. If you know it,
Yes.
the highest number that can go through the 50,000, the 15,000, and 180,000.
Yes.
But better you first look at those zeros, you remove them, and then you continue.
Okay, thank you.
Okay, Smart Elisha.
So for me, what I was asking, because I didn't understand this part here, whereby you say that 10x plus 3y is equal to 36, then you got 3 and put it here on the x part. Yeah.
Oh, Elisha, did you come in early or you came in a bit late?
My network freezed a bit when you were explaining.
Oh, okay. Okay, I'm going to throw some little light. Jonathan? Those who have, you can start plotting, members. Start plotting, start plotting. Jonathan?
Yes, thank you, teacher. What I'm asking is a case whereby the lines are dotted, all of them are dotted. What if I enlarge the figure using matrices by negative scale factor 1?
You do what? When they?
Like when all the lines are dotted, like they're not solid, all of them. The joining, there are cases whereby the joining lines, intersections are all dotted, and we don't need those points. And I figure like a triangle, what if I enlarge it by negative scale factor 1 and bring it inside, and I choose those intersections now?
That one is not right. Okay, let me say it's not right, but let me say, the moment you find that you have dotted points, your figure is made up of dotted points, just choose the points within the region. Because even if you include them, the meaning for less than or greater than, it means that we don't want that one to be part of the solution. So even if you do the intersection, you are talking about reducing and the rest of that, it means you want to include them, yet actually you shouldn't.
Thank you, teacher.
So here, just get those ones within the bound region and then work with those ones. So members, we are plotting. Philemon, is it Philly? Guilt?
Yes, for me, my question is still on the axis. So at the beginning of the approach, we said we laid X and Y. And there is some survival approach there. You said like when you are remaining with 3 minutes, for you on your axis, you first put the pickups and the buses. Now, what if for me, I just only label my axis as Y and X?
Okay, yeah, like you'll get some little marks, but that one I say that is for survival, that things, but that's why we need to plan better. But that is for survival now.
Yes, no, master. Like if it's not for survival, can I label the axis with pickups and rollies?
Oh, okay, I'm going to talk about the graph. Let us go and plot. I'm going to talk. Yes, Shiloh, you had a question.
Yes, teacher. No, teacher, it was about the other graphs. The other graphs. I was asking, there were some points you didn't plot, and I didn't understand why.
Which graphs? These ones?
Yes, first go back again.
Yes.
I go back.
Not that one.
Hmm.
This point of 0.9.
Oh,
I don't
like
understand why
choosing
you
it.
think. Yes.
Hey, okay, now you can test it. You can also
Yeah.
test it. It is okay. But like what I was saying, that the maximum, the smallest or the biggest value will always
Yes.
be provided in most cases by the points at the corner of the shape at these sharp
Oh.
points.
Okay, thank you, teacher.
Okay. Okay, now allow me now, I'm going to do the plotting also as you do yours. Let me go to my graph. I'm going to my graph as also you go to yours. This is my graph. Now, when you are plotting on these graphs, please, I want you to take note. One, for this particular thing, I don't have, unfortunately, I don't, let me see that. But I think I don't have a ruler. So I'm going to use my free hand, but for you, use a ruler. For me, this is what I will tell you. Leave 2 centimeters down. Here, do like this. Come here, go up as far as you want. But use a ruler, use a ruler, use a ruler. Let me say that is where my graph is. Now, after drawing that, you have noticed I've left only 2 centimeters this side, I've left 2 centimeters down. Because we don't need any negative. We don't need any negative. For these particular graphs, take it from today onwards. I only leave 2, I leave 2. You don't need any negative space, or you don't even need those negative numbers on your graph, unless there's somewhere where you need to plot them. But we are looking for the first marks. The first marks are going to come from our title of the graph. I told you that for any particular graph you do, you must have the title. That's where our marks are going to come from. Now, when you look at the question was clear. The question told you that show the feasible region of the relation on the Cartesian plane. So I'm going to be very clear also, and I will say my title is going to be a graph showing the feasible region between, I can say, between the number, write in full, the number of trips made by I think it is Rory, and the pickup by the pickup, I think is the one on Y, by the pickup and the lorry. That is my heading. But even if you say, but I don't want you to just write an open statement. A graph showing the feasible region. What is it showing? What is on the graph? It is showing the number of trips made by the pickup and then the lorry. That is the first one. Then after doing so, I'm going to come and look at my figures. I want you to first judge, look at the values you are going to plot. Ask yourself, how big are they? I have for X, first look through all the X values. I have 0, 2, 1, 2, 3. For this one, I have 0, 3. So meaning that for X, I can use a good scale of my choice because they are very small. Put the demarcation 0. I'll jump after. I told you when you jump after, it is a bit, it looks very good. 1, 2, 3, 4, 5, 6. It is okay. Then you ask yourself, what do I have along the x-axis? What did we rate? It was the number of trips made by the lorry. So here I will say number of trips made by the lorry. That's what you had for your X. Then here label well, X-axis. Avoid writing in this white space right here, X-axis. Then I also will come here and I say, this is my Y-axis. Then I say, number of trips made by the pickup. Now, what do I want you to note? Please don't write. Some of you love writing like this. Number of what. Never write like this, because that requires someone to tilt your paper and then check out what you wrote. No one has that time. In case the word is not fitting, put it on the second line. Put it on the second line. Then I'm also going to go back. I look at the values of y that I'm going to plot. I have 12, 2. Which other ones? I have 12, 3, 1, 2, and 3. Then I judge. I say, which scale can work for me very well? Can my graph reach 12? Yes, in case it can. Then why don't you use it? Then I can come and I say, I can start from 0. Then in case I want, I can say 2, 4, 6. This is 8, 10, and then this is 12. In case you don't want to use, I told you can use 2 different scales. Then you can start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That one is also very, very fine. Members, are we still together? Let me know in the chat whether we are together. Are we together? Okay, good. Now, we are going to do the plotting. As you do yours, I'm also going to do mine. Now, when you go back and check on the plotting, I'm going to first plot the first one we generated. When you go back and look at our graph here, the first one was 0, 12, 2, and 3. 0, 12, 2, and 3. So I'm going to come back here. I check out for those 2 points that I want to plot. It was 0, 12, and then 2 and 3. So I'll come. 0 is here, 12 is here. I plot like that. Then the next one was 2 and 3. 2 is here, and 3 is going to be here. Then I'll come, I put it there. Then I go back, I ask myself, what is the nature of the line? Remember, the inequality we are plotting is 90x plus 20y greater than or equal to 200 what? 40. So you notice that it is greater than or equal to, meaning I'm going to use a borderline. Then I'm going to come. Using a ruler, I draw a good straight line. But now for such a case, don't stop here. Extrapolate, increase it. Increase your line, make it very long. That's what I'm saying. Come, make it very long, extend it like that. And then after you are going to label and say that this line I've plotted is, now when you are labeling, be strategic, not to put with the, even at times I can advise that you label after you have found out the region that you want. Now I'm going to test. Remember, remember this is 90x plus 20y greater than or equal to 240. Then I choose. We said you can either choose where A is or B. Now, the moment I find that 0, 0 is this side, why don't I take 0, 0, not to waste my time? So this will be 90 times 0 plus 20 times 0 greater than or equal to 240. So this is going to be 0 greater than or equal to 40. Then I ask, does the inequality make sense? That no, 0 can't be greater than 240. Then I will come and I do the shading. So I will come, I do the shading, I do the shading, I do the shading. Now, after shading, I can now come and label my line, that this line I've labeled is my line. Which line is that? It is the line 9x plus, I think it is what? 9x plus 2y is equal to 24. Label it. After that, Patricia, a question?
So I'm sorry to take you back, but I just wanted to ask, like, in the equation, there's somewhere you put 2. Okay. Something where you put in the equation of 90x plus 20y is greater than or equal to 240. I thought in the table you put 2 instead of 0, so it's a little bit confusing. I don't know.
You put what?
You got that. You put 2 instead of 0. You put 9 times 2 instead of 0, so I don't know. I get that.
9, which one I put?
You put 9 times 2. I thought it's supposed to be 0.
Where?
Okay, where?
Oh, here.
Yeah.
Okay, now like here, like when you put 0,
Yeah.
Here we put 0, we got 12 for x.
Yeah.
That is okay.
Yeah.
Then when you put for y is equal to 0, we were getting a point, so we wanted to avoid a point.
Oh, okay.
Just because you wanted to avoid a point.
So if you want to avoid a point, you keep on trying out different numbers, right?
Uh-huh.
Okay, thank you.
Okay. But I've showed you that in case you try, don't waste a lot of time trying, because you may find yourself you are wasting a lot of what? A lot of time. So for such cases, what you do, I showed you at the beginning of the lesson what you can do quickly to check out whether you can be able to do what? To get that exact value. Okay, then we are going to continue. Now, that is the first line. I go to the second line. It was y greater than x. And the points we are plotting is 0, 0, 1, 1, 2, 2, 3, 3. So I'm going to go still back to my graph and I plot those. I don't know, you're going to let me mix a bit of colors to distinguish the lines. So the first point was 0, 0. Then I had 1, 1. I had 2, 2. I had 3, 3. I had 4, 4, 5, 5, like that. So you ask, our line was y greater than x. So this line is a dotted line because it doesn't have the other equal thing. So I'm going to dot it. Use a ruler. I will dot it. I do like that, like that, like that. Like that. Then after, I can label my line that this line is the line y is equal to x. Now, what am I going to do next is to test. I'm going to test either point this side or a point this side. Choose any point of your choice you want. Take an example, I can come and I say, I want this point. And choose whole numbers, don't choose those negative. So I want this point here. This point is my point, 5 and 2. So I'll come, I have y is greater than x. This is my x and this is my y. So my x I will put 2, my y y is 2. I will put 2 greater than 5. I ask myself, is really 2 greater than 5? No, 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 no. 2 can't be above 5. Or you can say, is 20,000 better than having 50,000? No, 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 no. So meaning that is the unwanted region. So you come and you shade it very well. That this is the region that I don't want. Now, this thing of testing, you do it on your answer sheet. You don't do it on the graph here. You do it on your answer sheet. Then, hope we are together on that point. Then I go to the next one. The next one is the last line. So when you go back, so you go to the last line. Okay, let me first pick Daniela. Yes, Daniela.
Why did you choose 5 2? Why not any other point?
Okay, you give me the point you want, Daniela.
5 8.
Okay, a minute. 5 8. Daniela, 5 8. 5 8 is here, not so?
Yes.
So you test, you say y is greater than x. So you have chosen 5 and 8. So this is x, this is y. So I say 8 greater than 5. Then I ask myself, Daniela, is 8 greater than 5?
No.
Daniela, is 8 greater than 5?
Yes.
Yes. Does it make sense?
Yes.
Meaning that part is the wanted region. So you shade the opposite.
Okay.
It is up to you.
You can't choose the same point. You can't choose like 9 9.
You can, as long as it's not along that line. Are you getting it?
Okay.
As long as it's not on the line. Now 9 9 is you are going to find it is on this line. So you can't use it. 9 9 is on the line. So that point shouldn't be on the line.
Okay.
Okay. Okay. Now we are going to continue to plot the last one. Now the last one, let more people are finishing. People are finishing. I'm also Starboy. Starboy. Starboy.
Teacher?
Yes.
Could I ask one more question? Could you go back to the graph, please?
Okay. Yes.
The graph. Yes. So, how do you know when to shed the unwanted? How do you know that's an unwanted? Why is it be the unwanted?
Okay. Choose for me any point. Which now, like unwanted is the one that doesn't make sense. The one that doesn't fulfill the inequality. That's what we call the unwanted. The one that does not fulfill the inequality. That take an example. Give me any point you want to test.
Maybe, for example, 8, 10.
8, 10. And I'm using, we are testing this line, the green one. So you'll find that they want y is greater than x. So this is x, this is y. So when you place it here in the inequality you have plotted, this is 10 greater than 8. You ask, is 10 greater than 8?
Yes.
Yes. Now that one makes sense. So as long as that part you have chosen is making sense, that is the wanted region. Then you shade the opposite one. Are we together?
Yes.
Now, if you had chosen a point below here, any point below here, it wouldn't have made sense, so you shade it also. The one that doesn't make sense is the one you shade. The one that makes sense, you don't shade it. Is that fine?
Okay. Yes, that's fine.
Okay. Now we go to the last one. The last one I'm going to plot. This is what I have. According to me, this is what I have. Yes, Mirembe and fine. So what I have, I think we had 0, 12 again here. And then we had 23. Yes.
I'm confused on this. I'm confused on this line of y is greater or equal to x. Where
it was y greater than x.
Where to choose the coordinates. At first you've chosen 5 and 2. But then I'm confused. Remember, you've chosen 5 and 2. And after like comparing it with the equation, we have shaded this part, the no region. And also when you've used the other, like when you have again chosen 5 and 8, you have again, okay, I'm totally confused on that line.
No, okay. Now, for this line, you stay on. For you, you choose from any region you want. Now, the other person who wanted us to choose from here up. For you, choose where you want. In case that point where you have chosen is not making sense, you shade it.
Yeah.
I don't know that you're getting it.
I'm confused.
Where? From where? Like I'm saying, when you choose 5, 8, 5, 8 is above here. So when you fill in here, you will get 8 is greater than 5, which makes sense. So meaning that is the wanted region. And we don't shade the wanted region. We shade the opposite side. That's why for it, it was just a confirmation that we shade this one.
Yes.
So don't choose both. For you, choose one side of your choice. And then after shade that.
Okay. Thank you.
Okay. Okay. Then we go to the last one. It was 0 and 12. Then it was 3 and 2. 3 and 2. I think my 3 and 2 is somewhere here. So I'm going to draw, but the line that we are plotting now, the line we are plotting is this line, which is going to be, I think it was 10x plus 3y is equal to, okay, that was 50,000 x plus 15,000 y is less than or equal to 180,000. Now, what are we going to do? This inequality is less than or equal to, meaning I use a bold line. So I'm going to come, I draw my good line. Draw yours in a good way. Something like that. Then after I'm going to label that this is my inequality that we plotted. I think it was 10x plus 3y is equal to 36. Then I choose either I say A or this side of B. But the moment I see that 0 is qualifying, I use it. So here I will have 0, 0. So I'll get 0 is less than or equal to 180,000. Then I ask, does it make sense? That yes. So this side of where 0 has been chosen makes sense. It is this side that does not make sense. So I shade that time. I shade. Then the last inequalities that we have to shade are the non-negative inequalities. So those ones I will just come and I shade here, shade here. I will come this side and I shade here, here. Then I'll have my graph completed. So that is how I come up with that graph. So now this graph you have drawn will have all, you'll be well contented that now at least I have the marks. 611.
Sir, can you please elaborate on how do we identify that the line is dotted and the line is not dotted?
Okay, you keep on. When I say your mom is going to give you pocket money greater than 10,000, what do you expect as the pocket money?
The money should be higher than what? Than that.
So such as, give us an example. It can be.
Let me say 10,500.
Good. So here, 10,000 is not part, not so?
Yes.
So mathematically, to show that it's not part, we use the dotted line.
Yes.
So whenever you find that it's not part, you use dotted lines, even if it is less than. As long as it's not part, you use dotted line. In case it is part of, then you use a bold line.
A bold line.
For
okay.
Greater than or equal to, less than or equal to.
Okay, sir, one more question. Sir, on the other calculations where you say that you got a point, I didn't understand the way you multiplied, like, for example, 10 times 3.
Which point?
Why first go back to the other calculations of 90x plus 20y is greater or equal to 240. Why did you multiply? No, not this calculation. First check onto the other calculation.
Which one?
I'm not seeing it. Where is it? Yeah, this one. Why did you multiply 10 times 3 plus 3y equals to 36?
Oh, here, because my x, I chose my x as 3.
Yes.
That's why where there is x is where I put 3.
3. Okay.
Then you continue. Because I was avoiding the whole numbers.
Okay, sir.
Okay. Then,
thank you.
Okay. I'm seeing another Daniela here. Okay. Now the rest, let me be tasking you to find the points, the optimal point. Be finding. Yes?
Excuse me, sir.
Yes.
Teacher, my problem is on the graph. Can you have a straight line and those lines don't meet?
It is possible, And the lines do not meet completely.
Like they meet, but like on the axis, maybe.
Yeah, it is very possible. Very possible.
Thank
you. Okay. Abby? Okay. Okay. I think...
Daniela is here.
Yes, Daniela?
Okay,
yes, I have a question. Okay, let Abby first talk.
Abby? Okay. Daniela, talk.
Sir.
On the graph? Oh, we are two Danielas. Let the other one first talk.
Okay, talk. And we...
Sir, good morning.
Morning.
Sir, my concern is about the objective function. Sir, the objective function is supposed to be used to see whether it's to maximize or minimize maybe the cost. Okay, sir, are you supposed to plot, let me say, like use the objective function on the graph?
No, you are not supposed to plot it. Okay, you don't plot it, that is the second approach I talked about, but that one I'm not going to teach you how to use it, how you can use the objective function on a graph. But people who do technology and design, they know how they can do the reflection.
Okay, so what is our objective function in this scenario? I want to know the objective function.
The objective function is that function that is going to help you to know how much money you spend on the trips when you hire them. How much are you going to spend? So that is the one of 50,000 X and the 15,000 Y.
But now, sir, I'm seeing, I think we have plotted this on the graph.
No, there are two conditions now. Like this one, it had to help us. We have not plotted the objective function because you cannot plot it. Because for it has two variables and it has unknown, which is the cost. So we are not sure of how much. The 180,000 was given us to reason out that when they make these two trips, the money we get must not go beyond the 180,000. So when we fill in the objective function, any answer we get shouldn't go beyond the 180,000.
Okay, sir. So meaning if maybe in the scenario, they give you the cost, but they don't give you like maybe the money here like 180, meaning that one is you're just going to use it as the objective function. Now,
Yes,
when they
give
you, maybe they give you a limit like 180, less than that's when you can use on the graph.
Yes, but even sometimes they are going to give you the profit things and the rest of that. So when they tell you, they can tell you, in cases for business, they will say, this business makes a profit of 5,000 when they sell this and it is. Now that one for profit is the one you use as your objective function.
Okay.
Okay. Allow me now to take... Yes?
Wait, one more.
Sir.
Yes.
Sir.
Yes.
On the graph, we have not plotted that y is greater or equal to 0 and x is equal to 0.
We have plotted it. Let me use now this one. When you check on our graph, you notice the one I shaded it last. This line here, this line, because the x-axis is the line y is equal to 0. That's why I shaded it. This line here is the one that is x. This one here, it is the line that x is equal to 0. So that's why we shaded it this side. And for it, always
thank you,
shade
sir.
that side. Okay.
Okay, then teacher, on the graph, how comes we have put the reduced inequalities? Why haven't we used the original ones, the bulky ones?
You put, as long as, and we don't put inequalities, I have put equations.
Yes, the equations. How comes we have used?
Put the one you want. Put those bulky ones. For me, I was minimizing time.
Okay.
Okay. And that one makes it clearer for someone marking you.
So my question is, how do you minimize?
Okay, now that's what we are going to. Okay, now let us go to that part. Now,
excuse me, sir.
Yes.
Back to the graph, please.
It is there.
No, the other graph, the last one. So for me, I'm confused here. Where like on that line, y greater than x. At first, we first used 5 and 2. And then it gave us a false answer. And then we shaded this downer region.
Yeah, because it was false.
Yes. Then we used 5 and 8. Then it gave us a right answer. And we shaded still the opposite side. So I was asking if that line y greater than x separates regions A and B. So that's my question. Does it separate? It separates.
No, here you don't have region A and B. Oh, okay. This line, yes, it's the one that separates region A and B down. It's the one that separates this one up and the one down.
But teachers, we can see 2, 1, 8. According to me, they're in the same region A.
Yes. And when you use it,
so master, when we used 2, it gave us a false answer.
2,
but
8?
we still
2, 8?
No, when we used 5, 2.
No, 5. Remember, here you must fill in very well. 2, 8 and 5, 2 are totally different points. 5, 2 is below. 2, 8 is above.
Oh. So
are you seeing the difference?
Yes, sir.
Hey.
Thank you, sir.
Okay. Now we go to the last part. So please ensure your graph is like this. This is how your graph should be. And what are the marking points? Now, one thing we have not talked about is the scale. Please do not forget to indicate your scale. So your scale, I'll expect to put for us your scale and say vertical. And here I've told you that report in 1 centimeters. That 1 centimeter represents 1 trip made by the pickup. Horizontally, 1 centimeter represents 1 trip made by the lorry. Hope that is okay. You say 1 centimeter represents 1 trip made by the pickup, 1 pickup trip. 1 thing represents 1 trip made by the lorry. So indicate the scale. So having the title, that is very good. Labeling it, that is very good. But don't forget, I've said write in words, number of, don't abbreviate like me. Have the title, clearly label. So here, let me put for you the marking point such that have the title, have your scale already written, clearly label, shade. And here even you are going to indicate, at times I love when people put that here you can put it somewhere in your work that the wanted region is the unshaded part. The unshaded part. Or you can put here a letter, let me say W and say W represents the wanted region. Because someone may, yes, you can say W represents the wanted region. Then have the title, have the scale label, shade very well, or shade the unwanted region. Clearly label your points here. Put equations. Do not put what? Yes, have good starting points. Some of you at times have hanging graphs without a good starting point. Have the starting points and clearly demarcate and have your arrows well. Avoid writing these arrows, those arrows. Have a clear arrow that will make your work very, very nice. So that's how you will score. Now, looking at this graph,
The graph is red.
Yes?
The graph is in
Okay, in case you are very accurate. Yes. So, yes, in case you are very accurate, having them in pen is very okay. Because like at times they mark your work at night. So when you use your pens, at times your work is very faint. But in case you are accurate, use a pen, no problem. No one is going to penalize you on that.
Sir.
Yes?
after you are like labeling the axis, we were like, we can label the reduced or the big ones. Now I thought like
labeling
for
the
example,
axis.
yeah, labeling the lines, sorry, using the equations. Like your scale is maybe 2:5, so in 30 and so on. Will you still label your line to say maybe 500, this plus, or you use the reduced one?
You get the same answer, whatever thing you fill in. You'll get the same answer. Okay. Okay. Then this is when I've put this graph, I've removed, and I wanted that to extract the points very well together. Now, those who have finished, I know some of you have extracted. So I've told you always look at the region. So this is one of my points. Those people who have used the calculators to solve simultaneously, you have noticed when you solve this equation, this line and this line, they're meeting there. Now, when you look here, you are noticing that here, you are getting, it's not an exact point. And to make it worse, this line is a dotted line. You have nothing to do with it. This one is a dotted line. You have no business to do with it. So what are you going to do? This is one of the points. Now check through and see, is there any other point within that I can take? There is this point along the line that I can read off. There is this point here that I can read off. And I told you we are always reading integer values. So check out which points you can read off. So personally, I have read off those ones. I've told you at least have 3. I've said at least 3 points. That is a very good thing, but not less than 3. Have at least 3 points. So I can read off this point, and then this point. Because others are appearing as points. Yes, Ruth.
Teacher, I'm sorry to take you a little behind. Still on this graph, I'm kindly requesting for clarification what exactly to label on my y and x axis, the number of pickups, the number of what, or I just randomly place them. Number of pickups, like I saw here, the number of pickups is on the y axis, then the number of lorries is on the x. Does it have any specific criteria, or I just randomly place?
No, now that one we have picked it from how we labeled it. Now, when you go back, Ruth, when we are starting the question, we said X represents the number of trips made by the lorry. So along the x-axis is where we shall put the lorries. Then Y represents the number of pickups made, the number of trips made by pickups. So we use the Y.
Oh, thank you, teacher. Okay. I understood.
Okay. Okay, now I go back to the graph. So those are the points that I'm going to have. I'm seeing very many hands. Yes, Daniela, your hand is still up. Jonathan, Hope.
Teacher, there's a point 2.5.
2.5.
Yes, some people are saying 1.8 is among, but I'm not seeing it being like just near the point, but it's not exactly.
2.5 is here. I can also read it.
What about 1.8? People are saying 1.8 is among.
1.8, yes.
But I don't think so.
Here, I'm seeing it on my graph. Zoom my graph.
Oh, yes.
It is there. Okay, good. Now, after, what are we going to do? Now, after reading off those points, I'm going to take you to another screen. Oh, I don't have. Okay, let me. After reading off those points, read off all the points like the way we have obtained them here. Now I'm going to come and I draw my table. I draw a good table. I'm going to come and I say, what is my table going to? Okay. Something I want. Okay. Okay. I don't. Okay. I'm going to come. Okay. Okay, good. I've seen what I wanted. I'm going to come, draw a good table. In your table, you are going to put the optimal points. Now, optimal points, you are going to put X, Y. And then you're going to put here your objective function. Don't forget our objective function. We generated it from here. The cost was from here. So I will go back and I come back here in my table. I say the cost XY. Then it was 50,000 X plus 15,000 Y. Then I write all the possible combinations we have obtained. So our possible combination, we had, I saw, let me go back to be sure. We had 0 and 12. So I write 0, 12. Then another one, people said 1, 8. Another one, people said 2, 3. Which one else did we have? We had this one here. We had this one, which is 1, 8. We had this is 2, 6. Okay, I'm going to include 2, 6. There is another one people mentioned. There is this one, which this one is a point. So that one is not productive. Which 2 and this is 2, 3. I think we have included it. 1, 8. Is there any other? Put in the chat. I don't know. 2, 4, 2, 5. 2, 5. 2, 5, eh?
Yes.
Okay, 2, 4, 2, 5. That's what people are saying. Okay, 2, 5. People are saying 2, 5. Hope it is there. But let me confirm. I want to be very sure. 2 is here. Where is 5? Here. Yes, it is there. Okay, now after we are going to fill into our thing here. So what you do, 0 and 12. So we shall say the cost. Here you have two options. Either you can say your 50,000 times 0 plus 15,000 times 12. Then you come up with the answer. So when I put there, I'm saying it is about 180,000. Then I put 1, 8. I do the same. 50,000 times 1 plus 15,000 times 8. Then I put the answer. That is about 170,000. Then I go to 2, 3. I say 50,000 times 2 plus 15,000 times 3. That one, the answer is about 145,000. Then I go to the next one. 50,000 times 2 plus 15,000 times 6. I get the answer. Oh, yes. I want you to confirm the answers I'm getting. I might write the answers when they are not. It's not what you're getting. In case there is any answer, in case there is any answer, so this is, I'm getting 190,000. Then when I put here, I have 50,000 times 2 plus 15,000 times 5. I get the answer. Times 2 plus 15,000 times 5. Here I'm getting 175,000. Members, kindly confirm that all the answers are okay, match with what you have. Do they match? You can indicate in the chat. Do they match? Yes, Linda is saying yes. Cabrin is saying yes. Patricia is saying yes. Okay, good. Now, we go back to the question. What did the question want us to do? When you go back, you are going to notice that I go back. The question wanted us, use the graph to find the possible number of trips to be made by the lorry and the pickup. Hence, find the minimum cost of transporting the bags of sugar. Minimum cost. Now, minimum cost, it means that you are looking for the one that saves a lot. I want to see whether people can give us the answer. Look in the chat. Nasona Juliet. I don't know why you are not getting the same answers. Juliet, unmute.
Morning, teacher.
Yes, good morning.
Okay, teacher, for me, I added 2, 4. coordinate 2-4, and I'm getting minimum 160,000.
Okay, now we go back and ask ourselves, do we have 2-4?
Yes.
Oh, you have added the 2-4 here?
Yes, it's there.
It is there, okay. So we are going to go back and put it there, no problem. 2-4.
It's the one with the minimum cost.
Okay, you multiply for us and you tell us.
It is 160,000.
160,000.
Yes.
Now, do you have 2-3?
No.
Why? Is it there on your graph? Is it there?
Yes, it's there.
Okay. Now, what could be our answer, members? 2-3.
2-6 is not there.
Yes?
2-6 is not there.
2-6 is not there. Okay. I'm using my graph. 2 is here. 6 is where? 2. 2-6 is out, members. I'm saying it's not there, not so? According to my graph, it is out. So I'm going to eliminate 2-6. It's not part. But those who are having it, like I told you, use what you have. In case for you have it, put it there. But according to what I have on mine, this one, I'm going to eliminate it. It is outside. And even you cannot, for it was even bigger. So here, our answer, we are going to look out for which one is giving us the minimum amount, which is 2-3. So now, how are you going to conclude? So we are going to conclude and say, the minimum cost, hope you are listening, the minimum cost, I'm not going to write everything, the minimum cost of transporting the bags of sugar is shillings 145,000 when 2 trips have been made by the lorry and 3 trips have been made by the pickup. That's how I conclude. I said the minimum cost of transporting the bags of this is 145,000 when 2 trips have been made by the lorry and 3 trips have been made by the pickup. So that is how I am going to conclude. Okay.
Yes, teacher, my question.
Yes.
Like, sorry for taking you back, but on the graph, does it mean we can't choose points from the dotted line?
Yes, you don't, because they are not part of the solution.
But we can choose on the solid lines, right?
Yes, you can choose a point along the solid line, but not on the dotted line.
And the dotted lines are those ones that have either greater than or less than equalities.
Perfectly said.
Okay, thank you.
Okay. Okay, I pick one hand. Gali. Gali or Sally. Okay, Gloria. Linda.
Teacher, when do you know that you have to use non-negativity function?
Like I told you, for non-negativity, for you include them everywhere. But if you can reason out, now like for this particular one, they were not so important because you would find yourself shading even where they are. But there are some questions whereby you are going to plot, whereby you are going to come plot, whereby most so for, I want you to, where you find yourself having only 2 equations. When you find yourself having only 2 equations, in most cases, never forget to write those negative inequalities. You'll find your region like this, whereby you have shaded this and you have shaded this. So here, the non-negativity inequalities are very important for you to include them. So here I will come and I include it because I have to shade this part. I also have to shade this part. So in order for us not to miss out, always include them, because I've told you their implication is that we can't have negative trips and we can't have negative things. That's why I want you to include them for whatever number you are doing, such that you can know that I cannot have anything negative as my answer for X. I cannot have anything negative for my answer for Y. And my answer can as well be 0 trips. That's what I'm saying. So include them for every number you are doing. Hope you have understood. Okay. Yes, Linda.
Teacher, good morning, teacher.
Morning.
Teacher, I was requesting you do activity 3 that we did yesterday.
Which activity?
Activity 3.
Okay. What is it about? I don't remember.
It's about packages of shirts and pants.
It is about?
Packages. Like, it's about packages of shirts and pants.
Okay. Have you given it a try? Or not yet?
Yeah, I'm trying it, but it's not working out. Like, it's not coming.
The graphs are not coming.
Yeah.
Okay. Okay. You are going to, you'll share with me what you have. But there are some specific. Yesterday I was mainly looking at you coming up with the equations, but it can come out. I think because I just estimated the amount, so the problem might have come from the amount of money. Okay. But you'll send me your working and I look at it.
Okay, sir.
Okay.
Sir.
Yes.
Morning.
Good morning.
For me, my issue is about the optimal points are not plotted. I mean, the optimal points on the dotted line are not recorded.
Yes. Okay. Now, kindly, what are you going to do? Now, yesterday we did quite a number. We tried out very many numbers because we are not going to go beyond this point. Now, what are we going to do? I want you now to try out at least one number. Try out one number on your own. You can try. Yesterday we looked at how we derive, how we derive. So try out one number we did yesterday. Take an example. You can decide to try out this number where we derive the inequalities. Try out and see, is it coming out? More so, I want you to try out numbers where they had order 3 parts, A, B, C. Try out. If at all it is this number, try it out. If at all it is this number, try it out. I want you now, for you just try out any number of your choice, as long as the number is what? Is complete. And then test out yourself whether now you can be able to plot, whether you can be able to conclude. I want you to be very careful when it comes to the conclusion, because you'll find that it is carrying about 3 scores. So when you don't conclude and you stop somewhere, you may end up losing the marks. So I want you to try out. You can, maybe in case you can inbox me. I am happy with the people who tried out yesterday. At least I've seen some of you who tried out, and I saw some of the work that you did, and the work was really very, very nice. So let me first stop sharing a bit here, and then I see how I can access some of these papers. There's something I want to show you. Yes. So now, what is very important, I want to repeat, what is very important is for you to obtain the what? The inequalities. That is the most important thing. As long as you obtain the inequalities, the rest of the things are going to be very easy for you. But the moment you fail to obtain the inequalities, then things are going to be very bad on your side. So always make sure you obtain the inequalities to be very, very safe. I wanted someone wanted us to just look at Waukesha. I want to get that paper such that okay, let me get it such that at least we can derive and then you try out on your own. Where is Wakisha? I want such that you can try out on your own how okay, I think it is here. You try out on your own to come up with a graph. Now, this was the Wakisha thing. It was saying, okay, hope the screen is big. Okay. It was saying that your mathematics teacher is planning to transport not more than 400. Okay, I think, okay, not more than 400 students to a seminar in a neighboring school located 10 kilometers away. He, however, doesn't know how many trips each vehicle will make so as to minimize the transport costs. After consultation with the manager, Super Free Express Bus Company, the teacher realizes that if all students paid, their total contribution should not be less than 360,000. The school is also to hire a bus which carries 64 students per trip and a minibus which carries 16 students per trip. The number of trips made by the bus should be at least 2, and those made by the minibus should be at most 6. The minibus should make more trips than the bus, and the charges will be this and this per trip of the minibus and the bus respectively. So then I told that after getting this question, for you, your task, first look at the task such that you know what is changing or what is varying. So they are telling you that help the teacher to find out the number of trips each vehicle should make. So meaning that the variables that are changing or what they want to minimize or what they want to look at, they want to see that if we use this option and what are the options available, that the options available is either bus or a coaster, meaning that what is going to be varying are those two vehicles, the bus and then the what? The coaster. So you are going to come and work out and say, now that I've known that it is either the bus or the coaster is what I'm going to let. Then I'm going to ask myself, when they were starting, what did they start with? Is that fine? So what did they start with? That they started after the Super Free Express Bus Company. You are not saying that they are starting with the company bus. So I will say that let maybe X represent the number of trips made by the bus. Let Y represent the number of trips made by the minibus. That is the first statement. Then I told you can summarize it in a table. So allow me now to, I'm going to use this space, but let me use this pen here that writes. Let me use this. So I can first come and summarize in my table here. Sorry, I know it's not the best. So I have the bus and I have here the coaster or the minibus. So they're saying after consultation with the manager, Super Free Bus, the teacher realizes this is the money and the school is to hire a bus which carries 64. So where there is a bus, I put 64. And a minibus which carries 16. Then I ask myself, what is the total number of the total number that the bus that want to go for the trip is 400. Now, after that, this is the capacity or the seating capacity. Then I go to the next one. What else am I going to form? Then they are telling you that the school is to have, okay, we have finished that one. The number of trips made by the bus should be at least 2. And those made by the minibus should be at most 6. I told you, the moment you find that they are using a conjunction between the two and you have inequalities, that one you are going to separate them. So this is one inequality and this is the second inequality. The minibus should make more trips than the bus and the charges will be this and this. Now you're going to look for the charges. And remember, after here, there is also another conjunction, meaning that you have two inequalities in between. Now for the charges, they are telling you, and the bus for the minibus, and now here I want you to be very careful. They use minibus and bus respectively. meaning that the first amount is for minibus. So this is 40,000. Then the second one is 90,000. But also at times you have to reason out that how can a bus charge you, how can a mini coaster charge more as you are writing? So you reason like that. But how much money are they going to collect? Or what are they expecting? They're expecting that 360,000. So down here, you put 360,000. Then you are going to come and form your equations. Now, the first one we have said is going to be 64x plus 16y. But they told that the number of students to be transported should not be more than 400, not more than. We said the moment you see not, that means there is unequal, not more than. So it will be less than or equal to 400. Now, however, yesterday I also told you, if they had told you that your mathematics teacher is planning for 400 students, then there you would have used greater than or equal to. So please take note of that. Then I go to the charges. This one charges 90,000 x plus the 40,000 y. Then I ask, should not be less than 360. Should not be less than. Which inequality are we going to use? Let me check out now. Should not be less than. Which inequality are we using? I want to see whether people are really there. Should not be less than. Which inequality are we going to use? Type in the chat quickly. Greater than or equal to. Very good. So here I will say greater than or equal to 360,000. Now that is my second equation. Then I go and I start interpreting these minor ones. The number of trips made by the bus should be at least 2. At least we say that is greater than or equal to. And our bus, we are representing it by x. So I will say x is greater than or equal to 2. Then I go to the next one. And those made by the minibus should be at most 6. So I will say minibus is y. At most 6 means less than or equal to 6. Then after that, there's another statement. The minibus should make more trips than the bus. Meaning that the number of trips made by the minibus, which is the y, should be more than the ones made by the taxi. Then after that, I'm going to put what is the school looking for? That the school is checking out how can they, what is the maximum number that the teacher can transport. So when they are transporting or when they are making the transportation, they are looking at minimizing the costs of the minimizing the cost as well as taking the maximum. So now you're going to generate. Now you're going to generate the possible combinations. So now how are you going to get the possible combinations? So here, do not forget, you are going to say y should be greater than or equal to 0 and x should be greater than or equal to 0. I repeat, this one means that your buses, you cannot have negative roots, and you cannot have negative roots made by either the bus or the minibus. That's why I'm telling you that always indicate them. Because if you don't indicate it, here, since you have already said y is less than or equal to 6, when we say y is less than 6, it means I can have negative. But realistically, can you have a negative? So, meaning that if you don't include y is greater than or equal to 0, it means that this statement you have made can be rendered useless for someone who interprets it mathematically. So that's why I want you always to indicate them. So y greater than or equal to 0, it will be very important because here you have already said y is less than or equal to 6, meaning that someone can take on any negative. Then you ask yourself, can we have negative roots? So that's why I'm saying, for you, include them. When they want, let them mark them. In case they feel it's not necessary, then let them leave them. Hope that is very, very okay. For this particular question, they can also ask you, find the minimum expenses. So to find the minimum expenses, then you must also do. Now here, what is the maximum number that the teacher can transport? Now here, if we are looking for the maximum number the teacher can transport, meaning that you are going to look at your region and find out those points. Now here, you are going to look in the region. You are going to look after, I don't know even how your graph will, after drawing, look in the region you have remained with. Obtain all the maximum points here, And then after obtaining the maximum points, you are going to go on and compare it to this. Are we together? You have 64x plus the 16y, and then you compare. When I put this and this, how many students can we take? When I put this and this, how many students can we take? Then you find out which option is giving you that particular the highest number of students that you see that the teacher can take. Remember, they have told you they shouldn't be more than 400. So now look out for the possible combinations, fill them here, because now this is the equation that is going to give you the maximum number of students, because this one takes 64, this one takes 16 children. So feed in the different options you are getting. In case this one makes 2 trips and this one makes 1, what do you get? Then find out what you are getting. So now this one is going to be your objective what? Your objective function of 64x plus 16y, because it's the one that you are going to use in order for you to determine the maximum number of students that they can transport. Let me hope that is very, very fine. Are we together, members?
Yes, teacher.
Okay. Yeah.
Can you try A?
Yes?
Can you try doing part A? Because I did the paper A and getting the number of trips each vehicle should make was 500 distance. Can you try getting?
Oh, help the teacher to find out the number of trips each vehicle should make to achieve his goal. Okay, now here, when you look, now part A, now this part has in fact even now I've seen another part. Because they want, for the teacher to achieve his part, one of it is he wants not to take more than that. But also you need to look at the amount of money. So now you are going to develop another objective function for expenses. Now, when it comes to expenses, still you are going to say my expenses are 90,000 X and the what? And the 40,000 Y. Still you look at your graph, find out which one is giving you an amount that is not less than 360,000. Are you getting it? Yes. So that is now how you are going to look at it. Hope I have answered. So maybe what my request can be, can we try out that number, each one of you, when you go back, since now I've showed you how we have the, how we do it, I want you now to obtain, but let me pick up a few hands and then we call it a day. We call it a day, but I want you to try to pick out a few, that number and you try out on your own. Yeah? So let me pick up the first one. Yes, Jonathan.
Thank you so much, teacher. This has helped us so much. This number, many of us filled it. However, I want to ask a question about the boundary lines. Do we label them on the graph?
Yes, you label them.
Yes, teacher. Thank you so much.
Okay. Sally Sandy. Okay, Sally Sandy, I'm not getting you. 11.
Thank you, sir. Sir, I would like to share with you one item only, so that you can elaborate me on how we can get the profit in case they give us such a scenario.
Okay.
So can I share it right now or?
Like you want to share the screen, eh?
Yeah.
Okay, share. Okay, as we go to another one. Antonia.
Thank you so much, teacher. So my question is, on the inequality that had the expenses, am I allowed to reduce?
Yeah, the expenses. Yeah, but like I said, first write that original equation, yeah?
Yes.
Then after you can reduce down.
Okay.
If you want.
Okay, thank you, teacher.
Okay. Grits or grits, something like that.
Yes, for me, master, I am asking, like, it's most especially part B or C, the last part where they ask you to calculate, where we use the points we've obtained from the feasible region. What if we get two optimal points and they are giving you this like the same answer?
That's where now I told you, you go back to the inequalities that you formed and you reason out. Most times for such numbers, there is a condition that maybe y must be greater than x, or x must be less than this. So you check out which option satisfies that inequality.
Okay, thank you, Master.
Now, like for this one we have done, this one I was showing you for Wakisha. They told that the number made by Z minibus should be greater than the other one. What does it mean? It means that when you get Y or X, when you find out that you are getting the same answers, it means that you go back and look at that inequality, that one shouldn't be above the other one.
I get it now. Thank you.
Okay. Victoria?
Teacher, for me, I was saying I had to give a concluding prayer.
Okay. Noel?
So for me, my issue is about I wanted to ask how did you talk about the title?
The title should. Yes, we said you say a graph showing the feasible region and then indicate what are you plotting, that it is between the number of pickups and the number of trips made by the lorry.
Okay.
So a feasible region is that region that contains the wanted region.
Okay.
Agesa?
First of all, thank you, teacher. You've done a great. And now, my question is,
yes?
But if you get the feasible region, which is very small, it's like a dot. Is it correct?
I beg your pardon, when you get?
Region which is very small, like it's like a size of the dot.
When you get? I'm not getting. When you get? I beg your pardon. I didn't speak you well. When you get something? Oh. Okay. I didn't pick your question, but you can put it in the chat. Ramadan? Ramadan? Yes?
It's very small.
My question is, after drawing the maximization table, like for the A part, like you're going to find the number of students in the B part, are you also going to draw another table, or you're going to use the same one?
Oh, remember the objective functions now differ. So meaning you have you can reason basing on the objective function you have. So better you have another table, you basing on the other objective function, but also factoring in that also the money must be fulfilled. You not only look, now you look at both. You look at the money you are getting, and then you look at the money that you are going to spend in that trip and vis-a-vis the high number. So you look at both.
Okay, thank you.
Okay. Then Daniela?
Okay, sir. Once again, on our graph, are we going to also have this inequality of 60,000 x plus 40,000 y equals to 360,000?
Yes, that one. That one is an inequality you plot.
Yeah, thank you, sir.
Okay. Kalema, is it Kalema or Queen? Any of you should unmute.
I beg for your pardon on the part where you were talking about the negatives.
Then I beg, where exactly? Yes. Okay, like I told you, we cannot have negatives. We cannot have the negatives. So that one you can ignore it. You cannot have the negative. Okay. Yeah. Okay. Lastly, Queen. You cannot have negative, so don't expect to have negative.
Can I as well know how to formulate the title?
Okay, the title, you are going always to say a graph showing the feasible region. Then after that, clearly tell us what is it that you are doing. Which it is about what and what, number of trips and this. It's about cows and maybe goats. It's about this and this. But clearly show a graph showing the feasible region.
Thank you, sir.
Okay. Okay. I think, don't you think those questions are enough for now? Okay, lastly, Hope.
Okay, sir, mine, I only need your WhatsApp number.
Okay, WhatsApp. Okay, it is there in the chat. I have seen it, someone posting it there in the chat. That one. Marcin, you can send it to her. Okay, now when you look in the screen, someone wanted us to go through this. He's saying Marvin is in partnership with a hotel and he supplies chairs depending on the amount of money deposited on his account. However, he has a problem of not knowing the exact quantity of furniture to supply, which causes shortfalls. This weakens is a major, okay, I think source of this first question. In his factory, Marvin produces two types of chairs, namely classic and modern types. Each classic chair requires 3 hours of woodwork and 2 hours of furnishing, while each modern chair requires 2 hours of woodwork and 3 furnishing. The factory has 120 hours of woodwork and 100 hours of furnishing available per week. Each class generates a profit of this and this. The maximum profit made in every week is reinvested back into the department of woodwork. Okay, well, determine the number of chairs of each type you must deliver to the hotel. Help Marvin to determine the amount of profit. Yes, so this is the linear programming number whereby they have mixed quite a number of what? But what is varying, 11 for this one, is the number of classic chairs and the modern chairs. So you can say, let X represent the number of classic chairs and let Y represent the number of modern chairs. So when you look at it, you are noticing that they have woodwork and there is thing for furnishing. So there is some time they take for woodwork and there is some time they take for furnishing. So you can say now for woodwork, you are noticing that it takes 3 hours to work on the classic chairs. So you say 3x plus 2y because they take 2 hours to work on woodwork for the modern chairs. So you say 3x plus 2y should be less than or equal to 120 because they have told that is the available hours that they have. And we say that for available hours, you say less than or equal to. So do you say 3x plus 2y is less than or equal to 120? Then, what? Okay, there's something I thought. Okay, then you form for woodwork, you form another equation for furnishing. So for furnishing, you say it takes two, this is, okay. So here, like you can notice that you will say that X is the number of what is about for the classic. Then you say Y is for the modern chairs. Then here, you when you are summarizing, I told you are going to summarize and say, these are classic, and I have the what? The modern one. Then modern, you have two things. You have the furnishing. Yes, I think the furnishing, and then you have the other thing of what? Woodwork. Then when you read, you say that each class requires 3 hours of woodwork. So woodwork is here, 3 hours. And then for furnishing, it requires 2 hours. Then but then you I don't know. Okay, then you'll go back here and say that for modern chairs, they require 2 hours of woodwork. So modern, you'll put here 2 hours and 3 hours of furnishing. I think it is like that. Then after you say, what is the available number of hours? Then you say that for woodwork and woodwork has 120 hours. So you come here under woodwork. The total will be 120. Then for furnishing here, the total is going to be 100. Then those are the two equations. So you're going to form an equation about furnishing and another one about woodwork. So you will say 2x plus maybe 3y, since that is the available hours, should be less than or equal to 100. Then you say 3x plus 2y should be less than or equal to 120. Those are the two equations. Then you go through and you say, they say that this one makes a profit of this, something like that. I've written in it, I'm not saying it. Then you say, this one makes a profit of this and this. So you form that profit, that 50, which profit are they making? That will be the one you will use to find out which one generates more profit. Then after you add x is greater than or equal to 0, y is greater than or equal to 0. And then after you continue. So I don't know whether I have helped a bit. 11.
Yes, you are well passed. Thank you.
Okay. 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 I think in the chat I'm not seeing. Okay. 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 So you'll finish that number. You can send them and they try out. And then you can, but I have to now, like here where you find that the concepts have been mixed, it is always better summarize in a table to avoid mixing the concepts. So here now, when you look at this particular number that they have shared, you are noticing it has only,
maybe
you will notice?
put the number from a friend or something. Don't say you're a high school kid, you screen. Yeah.
Okay. So,
or yeah, just
okay. So you'll find out those who can take a screenshot, you will also try out this number in your free time. Yeah. Okay. So allow me that let's end at this point. Tomorrow we shall start on something else, and we shall be starting. Let me see whether we can do some few numbers within this element of construct, and then we see how we can end. But you can send in some suggestions in my inbox. Yeah. I think the number has been okay. Okay, let me end here. Thank you so much. Let me ask Victoria to lead us in a closing prayer.
Okay, thank you, teacher, for that lesson. Let's humble ourselves for prayer. Loving Father, we thank you for a new day. We thank you for the night. We thank you for the gift of our teacher. We pray that you may add our teacher energy of teaching us. We pray for our parents. We also pray for ourselves so that the things they teach us, we may understand them. We also pray for our forthcoming exams. In Jesus' name I've prayed and believed. Amen. Teacher, finished.